Course of Chemistry. 4. Serve as an introduction to this science. By Nicolas Lefevre, Royal Professor in Chemistry, and Fellow of the Royal Society of London. 5th edition. Revised, corrected and augmented with a large number of operations, and enriched with figures. 1st volume. Editor's Preface. From the Chemistry of Glazer's Fever. If we had the medicine of the simples, such as the first men had it, or that most animals have, we would have recourse neither to pharmacy nor to chemistry, and the human body would be much better for it. But we must submit to the present fate of humanity, and seek to preserve health when we are fortunate enough to possess it, or at least to restore it when we are deprived of it. For more than 800 years we have applied ourselves to these two arts so useful to man. At first they were treated very imperfectly. The Arabs extremely embarrassed the pharmacy. And the chemistry practiced by the ancient Egyptians was not turned on the side of health, they had quite another object. But since then, it has been put to more legitimate use. Practice and reflection, sometimes even chance, have given rise to discoveries. In this way everything has been perfected and is still being perfected every day. The Germans are ahead of us in this kind of work. Most of their physicians employed in the colleges of mines occupy the best part of their leisure with their furnaces, and what does honor to this science is that even princes do not disdain the knowledge of it. Basil Valentine, Paracelsus, and after them Dornius, Diodor Enchion, Ulstad and Gessner, applied themselves to it successfully, and caused others to follow in the same footsteps. And all of them, including the first doctors of their sovereigns, today make it their duty to devote themselves to this science, which is very laudable, when one knows how to contain it within just limits. It is not, however, that pharmacy is not well practiced throughout Germany by apothecaries. One is even astonished, when one enters their stores, to see the abundance of their preparations, as well as the order and the cleanliness which they take care to maintain there. This concerns especially the imperial cities, where the number of apothecaries is very limited, and it is even necessary to employ a considerable amount of wealth there to acquire a background in pharmacy, and it is precisely among the Germans that the axiom that the apothecary must be rich is verified. And there are pharmacy shops, which sometimes amount to more than £1,000,000, as is the case in Strasbourg, where with the king's apothecary, there can only be 4. For the whole city, albeit large and densely populated. From Germany chemistry did not take long to pass to Italy, where Fioraventi, Fumanel, Fallope, and even an illustrious virtuoso, Isabel Cortese, applied themselves to it with success. This science came almost at the same time in France, as we see by the famous Fernel, first physician to King Henry II, who speaks of it in his works. Jean Libaud, doctor of medicine from the University of Paris, wrote much more about this science than he practiced it. We see, however, that he gives quite good principles in his book of the rustic house. Crush, who had traveled in Germany and throughout Austria, was one of the first among us to write about it on principle. His Tiracinium Chemicum is not, however, without many faults, which his commentators, whether Latin or French, have been obliged to correct. Then came Guillaume d'Avisson, Scotsman retired to France, who fortunately applied himself there. Besides nature, which he had studied well, we find in him a great fund of reasoning, and although there are some mores in his pyrotechnics, we see useful and singular operations there which have since been neglected. After these two artists, and almost at the same time as the latter, several others were formed among us. However, I will only talk about the main ones. Nicolas Lefevre and Christophe Glaser, so I am publishing a new edition here, are almost the same for the substance of the operations. I nevertheless report how they differ from each other. But the one who shone the most for ordinary use was Nicolas Lemery. The latter, who taught this science in Paris for nearly 40 years. Since 1672, until 1710, serves as a guide for beginners, and can form a provincial apothecary, because those of Paris have superior knowledge to that of this artist. His chemistry course, which is very methodical, has not failed to have a reputation. It has even been translated either into Latin or into some of the living languages of Europe. However, How many necessary, useful and curious things could one not add to his work, which even needs to be rectified on many occasions by a skillful hand? This is no doubt what we are working on in the new edition that we are preparing. Besides his chemistry, which is his first work and which in the first 3 editions, only formed a very small volume in 12, we also have a pharmacopoeia by him, collected from all that has appeared in this genre, but which seems inferior to that of Charis. He also gave a universal dictionary of simple drugs, quite curious and more exact than that of Pommet. A treatise which he published on antimony, was exposed to criticism from people better educated than him on this mineral. I was not a little surprised to see with what boldness he gives patients preparations of antimony, which he imagines or which he ventures for the first time. We nevertheless feel in his reading that he had not seen those of Basile Valentin and such 10, both Germans, whose works are esteemed by connoisseurs. Lemery's chemistry has not prevented skillful people from pursuing the same career, with less scope and detail, in truth, but with more enlightenment and criticism. This is what must be said of M. de Saulx, doctor of the Hospital of Versailles, who gave in his new discoveries on medicine, many chemical operations equally useful and curious. He did not, however, form a body of principles, they are only particular operations. M. de Senac, a famous physician attached to the house of Saint Cyr and to the Hospital of Versailles, has earned the approval of the most learned artists and the most skillful philosophers by his new course in chemistry, which was published in 1737, a new edition larger than that of 1723. M. Roth, German doctor, also entered the ranks, and his introduction to chemistry was translated into our language in 1741, and thereby it was naturalized French and is decorated with several beautiful preparations. Mr. Macker, after having given the theory of this science in 1749, published the second part of it in 1750, which contains a great number of excellent operations. Finally, we are satisfied with the impatience with which we awaited the work of a great master in this art, and whose profound knowledge led the Chancellor to choose as royal censor of chemistry books. He performs it with great discernment, accuracy, and diligence. It is a testimony that the truth obliges me to give him, with as much justice as pleasure, to make known the frank, obliging and just character, which constitutes the honest man, and the good citizen. You can clearly see that it is M. Malouin, a famous doctor I am talking about here, whose lessons I once took advantage of in Paris. The medicinal chemistry which this skillful man has just published shows that he is no less expert in the practice than in the theory of this science. Everything is marked in it by a great master, all the operations he gives are essential, extremely well chosen and very useful. I would gladly have taken a few articles from it to enrich the edition I am giving of Lefevre and de Glaser. But everything is to be noted, as much for the choice of operations as for the manipulation, even for this delicate manipulation which characterizes the great artist, who knows how to combine the practice of chemistry with the intimate knowledge and experience of medicine. But what one would not believe if the impression did not prove it, a man of status from Brittany, who took a liking to this science, gave something new himself. It is M. Le Comte de la Garie, whose hydraulic chemistry, which appeared in 1745, is approved by the ablest physicians of Paris. It furnishes a simple means of extracting the essential salts in the 3 kingdoms of mixtures, by mere trituration with common water. England and Holland did not want to give it up to the French or the Germans. No sooner had chemistry begun to be practiced by these 2 nations than it was taken as far as it could go. This science found among the English towards the middle of the last century the Knight Digby, Chancellor of the Queen of England, wife of the unfortunate Charles I. And this lord did not apply himself to it without success. To occupy his leisure, he had given up in some other parts of literature. But the relief of the sick and perhaps the care of his own health, inspired him with a taste for pharmacy and chemistry, and today we have a part of his preparations, first printed in 1669, and reprinted in Holland in 1700, with many mediocre operations, which are not by the first author. We have added to it, however, his treatise on the powder of sympathy, a remedy which he was the first to make known. The night boil which comes next, far outweighed the Digby night for chemical operations. He even employed very considerable sums there for more than 40 years and formed skillful pupils there. The remains of his laboratory, which passed to Mrs. Godefroy father and son, would form a strong complete of a less opulent artist. The works of Chevalier Boyle furnish proofs of a great fund of reasoning in all parts of philosophy, as well as of his diligence in work and uncommon sagacity. The whole city of London still bears advantageous testimony to the order and fidelity of the preparations of Mrs. Godefroy, who have always prided themselves on testifying that they had worked under the eyes and under the direction of Chevalier Boyle, Wilson, printed in London in 1699. After the two Van Helmont father and son, the Netherlands, especially Holland, has produced in Messrs. Lemmert, Barthuizen and Boerhaave, three of the most skillful men they have had in this genre. The last two especially each gave a course in chemistry, Barthuizen in 1718, and M. Boerhaave in 1731. Both, but mainly Mr. Boerhaave, shows the deep knowledge he had in medicine, philosophy and natural history. The first volume of its Elements of Chemistry is superior to all that had been given hitherto for theory, but the second volume, which contains the practice of this science, does not correspond to the idea that had arisen the first part. However, it deserves to be reprinted among us. Perhaps the bookseller would have done better to provide a French translation with the necessary augmentations to perfect what concerns chemical operations. I pass many other writers who have endeavored to elucidate only a few parts of this science, and I retrace my steps to say a word about the two famous artists whom I am reprinting today. Nicolas Lefevre, who was French, was brought up in the Protestant Academy of Sedan, so it appears that he was of the so-called Reformed religion. He studied pharmacy and chemistry with so much care and success that he was chosen by Mr. Vallet, first physician to the late King Louis XIV, as a chemistry demonstrator at the Jardin Royal des Plantes at Faubourg Saint-Victor. He had a good reputation here, was sought after and worked with advantage. But Charles II, King of Great Britain, wanting to establish the famous Royal Society of London, closed a chemical laboratory in St. James, one of his royal houses near Westminster. Nicolas Lefevre was called there to be in charge of it. He did not think he had to refuse this mark of distinction from a great king, who did him this honor. Being in a country of opulence, keep healthy, he had the opportunity to make many experiments. And working, moreover, at the expense of a prince, he made more such singular preparations in a year than he would have dared to attempt in his whole life if he had remained a simple private individual in Paris. This is what gave him reason to considerably increase his chemistry, the first edition of which appeared in Paris in 1660, in 2 volumes in octavo, 2 others in 1669, and a fourth in 1674. And it was probably in 1664, that he was called to London, where he published in 1665 a dissertation under this title, Discours sur le grand cordial du Sieur Walter Raleigh, in 12. He died there and had known Mr. Boyle there, whose taste was decided for chemistry in which he shone for so long. Lefevre should not be regarded as a vulgar chemist, he should be considered as a naturalist philosopher, who is not content only to extract mixtures as a simple practitioner, which can be used in pharmacy and medicine. He goes further, and even penetrates into the nature of beings, of which he knows how to develop all the properties by a just reasoning and solid. This is what distinguishes him from all those who have embraced the same profession. We can say that we have an obligation to him to have one of the first, reformed, rectified and put in a better order the whole pharmacy, as we will see by the parallel that he draws of the old preparations with those that he has published, and the apothecaries who love their reputation and their advantage, should not dispense with following it step by step. I know that since Lefevre, we have continued to perfect pharmacy and chemistry, but we followed him as he himself had followed Sulphur, the first physician of the late Emperor Leopold. This is how we arrive at perfection, as soon as each one tries to contribute to it on his side. Christopher Glaser only appeared after Lefevre. He has clarity and precision on his side. As for the principles, he does not differ from Lefevre, to whom he seems to have succeeded in the employment of demonstrator of chemistry at the Jardin Royal, where he was similarly called by M. Vallet. I didn't think I had to reprint all of his chemistry, so as not to make useless repetitions. I have chosen only the preparations omitted by Lefevre, or those in which they differ from each other. Glaser did not pursue his career as honorably as Nicolas Lefevre had done. He was implicated in the odious affair of the Lady of Brinvilliers in 1676, with which he was found to have too intimate a relationship for an honest man. He was not, in truth, involved in any of the crimes of this lady, but always dangerous suspicions in matters of poison made him suffer for some time in the Bastille. He came out of it, but he did not long survive this disgrace, and died in the time that he reviewed in 1678, his work to give a new edition more complete and more detailed than the previous ones. He was at the third part, which concerns animals, but a skilled hand, it was the famous M. Charis, undertook to lead the work to perfection. Thereby the public has lost nothing. He even inserted a small treatise on the Royal Theriac, which I am using in this new edition. Let us now see what I have done to perfect the one I give from these two authors. Lefevre's Chemistry, which originally consisted of 2 volumes, in the form of 3 in this one, because the reader's convenience demanded a little enlargement of the typeface, which in the last editions was too small for ordinary reading. But to make the volumes equal and of a reasonable size, each of them contains particular additions, relative to the matters that have been treated there. These additions placed at the end of each volume, are drawn from all that we have good ancient and modern authors. And as these additions were not sufficient to fulfill my purpose, I have added 2 volumes of supplements, namely the 4th and the 5th, both drawn either from Ethmiller. Besides the necessary and useful preparations, we find some which are curious and which could perhaps go further and become of some consequence. As for modern French authors, I have made them known to give everyone the justice they deserve, and thereby restore it to myself. It is commendable, it is right to make known those to whom we are indebted for a few important remarks, it is a duty of gratitude. I did not fail to put tables always necessary in the books of detail, in which I followed the great masters who preceded me, however Lefevre and Glaser had failed. When we have read any book whatsoever, a good table serves as a repertoire to be able to make use of it. It is the soul of these kinds of works. All the readers are not in condition or even lack the time necessary to make collections, and sometimes one forgets in one's collections a matter which at first seems unimportant, and which nevertheless then becomes so in the time one thinks about it the least. The differences between Lefevre and Glaser have been placed at the end of Volume V of this edition, where we have similarly placed the models of the furnaces inserted in the Chemistry of Glaser, and of which some seem very well imagined, and are more useful and even much more convenient than the ordinary furnaces. Opinion of Nicolas Lefevre. Although I am separated from France, by a long journey, and that I have devoted my studies and my work to the King of Great Britain my benefactor, and to the peoples who fill his kingdoms, however I feel obliged in the conjuncture of the 2nd edition of the treatise on chemistry that I gave to the public, to make by my compatriots the remedies that I made and practiced since I left Paris. And as I have known since I have been in England, the various accidents of scorbutic diseases, so I have applied myself to the search for specific remedies, and capable of combating this strange disease, which attacks our whole substance, which alters and changes the mass of the blood, and which causes vague and fixed pains, spontaneous lassitudes, and the swellings which are attributed in France to fluxions and rheumatism. I very willingly communicate what my work has made me discover anew, and what I have learned through association with the most learned and most experienced doctors, who do me the honor of visiting the Royal Laboratory, and to receive me in their profitable conversation. There are remedies drawn from plants, animals and minerals, which I have placed in their own class, while waiting for me to give new remarks and new remedies, as much for what concerns the theory, as for what look at the practice. Farewell, dear reader, enjoy my work and I am grateful for it. From the Royal Laboratory to the Palace of St. James in London on 1662. By your very humble and very acquired servant N. Lefevre. Preface to the 3rd edition by Christophe Glaser. The favorable reception which the public gave to the preceding editions of this book, made me undertake this 3rd, where I tried to accommodate myself entirely to the intention of the author, since the first time that he put this book to the day, he did it only in the thought of being useful to all those who like chemistry, by giving them the explanations of the very hidden things, with a very simple and very easy way to practice them. In the 2nd edition, he not only enriched it with a few figures, and augmented it with new experiences, but he also accompanied it with a dedicatory epistle to Monsieur Vallet, who was elevated to the position of first and very worthy doctor of the late King Louis XIV, in the King's Garden, where he showed and his sincerity, both by his work and in his writings, and the desire he had to recognize the honor he received by satisfying the intention of his benefactor, and the inclination natural that he had in the operations of chemistry, in which he made it a duty and a pleasure to communicate his insights to everyone. He was all the more estimable, as the method he left us is clear and easy to practice. All the preparations he teaches in this small work, where one finds in a few words the whole substance of several great books. Those who will take the trouble to read it and consider it well, will not notice anything boring or superfluous, or even anything omitted from what one should know. And although we do not find there the preparation of all things, we will nevertheless find their examples sufficient for the most necessary operations of this beautiful art. We must make sure that he does not give the slightest operation, without having previously practiced it, and that we cannot do after him, by following the rules he has prescribed, because far from hiding any skill, he sincerely discovers all the proper means to become a good artist, and all the circumstances necessary to achieve greater knowledge by working. He speaks only very succinctly of the theory, but he says enough to forget nothing of what it is necessary to know about the operations of minerals and plants. For the third part, which deals with animals, we warn the reader that we have taken care to serve him usefully in this edition, and that seconding the zeal of the author, who apparently prevented from death, had not put the last hand to this section, we present it to him more complete and more complete, either by the communication that we have had of his papers since his death, or by the happy help that has lent us a person so enlightened in the deepest of physics, and in the finest of medicine, only well-intentioned for the public good. This person was kind enough to steal a few hours from his private studies, to dictate to me the best part of what will be found in augmentations in this treatise, among other things on the occasion of the viper. This same curious, it is Mr. Charis, here again makes a free present to the posterity of a truly royal theriac, which he had invented and carefully researched only for his own use, and which for its good effects must prevail over that of the ancients, which was intended only for emperors and crowned heads. Receive, then, dear reader, in good part all my attentions which I dedicate with pleasure to your usefulness. Here again makes a free present to the posterity of a truly royal theriac, which he had invented and carefully researched only for his use, and which for its good effects must prevail over that of the ancients, which was not destined only for emperors and crowned heads. Receive, then, dear reader, in good part all my attentions which I dedicate with pleasure to your usefulness. Here again makes a free present to the posterity of a truly royal theriac, which he had invented and carefully researched only for his use, and which for its good effects must prevail over that of the ancients, which was not destined only for emperors and crowned heads. Receive, then, dear reader, in good part all my attentions which I dedicate with pleasure to your usefulness. Approval of Doctors of the Faculty of Medicine of Paris. We, the undersigned doctors regent in the Faculty of Medicine in Paris, have read this treatise on chemistry composed by Christophe Glaser, where most of the chemical operations are described with great clarity and judgment, and have judged it worthy of being printed by new. This third edition being enriched with some necessary observations, and with several very curious and very useful descriptions. Made in Paris this October 25, 1672. Levignon. Of Towns. Poilem, Dean. Approval of Mr. Malloyne, Censor, Royal of Chemistry Books. I have read, by order of the Chancellor, the abridged course of chemistry by Christophe Glaser, with the additions which have been appended thereto, in which I have found nothing that could prevent its printing. Made in Paris this June 9, 1749. Malouin. Approval. I have read by order of the Chancellor, I have approved the treatise on chemistry of Lefevre, and C. Made in Paris, this January 2, 1749. For duplicate Malloyne. King's privilege. Louis, by the grace of God King of France and Navarre. To our beloved and loyal councillors, the people holding our courts of Parliament, masters of ordinary requests of our hotel, Grand Council, Provost of Paris, bailiffs, seneschals, their civil lieutenants, and other our justices who may belong, hello. Our aim the Sieur d'Abrège made us explain that he would like to have reprinted and given to the public a book which has for title, treatise of chemistry of Lefevre, if we would grant him our letters of privilege for this necessary. For these reasons, wishing to treat the exhibitor favorably, we have allowed him and hereby allow him to have the said book reprinted in 1 or more volumes, and as many times as he sees fit, and to have it sold and debited by all our kingdom for 9 consecutive years from the day of the date hereof. Let us forbid all people, of whatever quality and condition they may be, to introduce foreign printing into any place of our obedience, as also and all booksellers and printers to print or have printed, sell, cause to be sold, debit, nor counterfeit the said book, nor make any extract from it, under any pretext whatsoever of increase, correction, change or others, without the express and written permission of the said exhibitor, or of those entitled to him, under penalty of confiscation of the counterfeit copies, and a £3,000 fine against each of the offenders, including a third to us, 1/3 to the Hôtel Dieu de Paris, and the other third to the said exhibitor, or to whoever will be entitled to him, and all costs, damages and interest, provided that these presents will be registered throughout on the register of the Community of Booksellers and Printers of Paris, within 3 months of the date hereof, that the reprint of the said book will be made in our kingdom, and not elsewhere, in good paper and fine characters, in accordance with the printed sheet, attached as a model under the counter seal hereof, that the applicant will comply in all respects with the regulations of the bookstore, and in particular that of April 10, 1725, that before exposing it for sale, the print which will have served as a copy and reprint of the said book, will be delivered in the same state where the approval will have been given therein, in the hands of our very dear and loyal knight the Sieur d'Aguesseau, Chancellor of France, Commander of our orders, and that 2 copies will then be placed in our public library, one in that of our Château du Louvre, and one in that of our very dear and loyal knight, Sieur d'Aguesseau, Chancellor of France, all under penalty of nullity of the said presents, of the content of which you order and enjoin to make enjoy the said exhibitor and his assigns fully and peacefully, without suffering any disturbance or impediment to them. Want that the copy of the said presents, which will be printed throughout at the beginning or at the end of the said book, be held to be duly served, and that to the copies collated by one of our faithful advisers and secretaries be added as at original. Command we first let our bailiff or sergeant on this requirement, to do for the execution of these all required and necessary acts, without asking for other permission, and notwithstanding the clamour of Harrow, Norman charter and letters to this contrary. Because such is our pleasure. Given at Versailles the 11th day of the month of January, the year of grace 1749, and of our reign the 34th. By the King in his council. Saintson. I, the undersigned, acknowledge having ceded and transferred to Mr. G. Noel Leloup, the entire privilege of the above book, which is entitled, Treatise on Chemistry by Lefevre, to enjoy it as it belongs to him. In Paris this July 28, 1749. Jean d'Aubure. Registered in Register 12. Of the Royal Chamber of the and Union of Booksellers and Printers of Paris, and Degree 106, Ground 90, in accordance with the regulation of 1723. Which makes sex, art. 4. To all persons of any quality whatsoever, other than booksellers and printers, to sell, debit and have displayed any books to sell them in their names, whether they claim to be the authors or otherwise, and with the responsibility of providing the aforementioned room with 8 copies prescribed by art. 108, of the same regulations. In Paris on March 11, 1749. G. Cavalier, Syndic. Treaty of Chemistry, in the form of ABREGE. Preface. Those who today want to make chemistry pass for a new science, show the little knowledge they have of nature and of the reading of the ancients. I say first, that they do not know nature, since chemistry is the science of nature itself, that it is by means of it that we seek the principles of which natural things are composed, and that it is still science that reveals to us the causes and the sources of their generations, of their corruptions, and of all the alterations to which they are subject. I said secondly, that they were ignorant of the reading of the ancients, since it is from there that they took occasion to philosophize, and that their facts and their writings clearly show that this art is almost as old as nature itself, which can be proven by Holy Scripture, which teaches us, that from the beginning of the world Tubal-Cain, who was the 8th man after Adam, on the side of Cain, was a forger of all kinds of brass instruments and of iron, which he could not do without having knowledge of the mineral nature, and without knowing that this mineral nature contains the metallic nature, which is the purest part of his being. Now this can only be learned by means of chemistry, since it is chemistry which teaches us how we can draw a metallic, ductile and malleable body from these mineral bodies, which are formless and friable. What makes us conclude that he had received this scientific art from his predecessors, or that he himself was the inventor? What I have just said can be proved by the oldest authors, and those who are most worthy of being believed. Thus we see that Moses took the golden calf, idol of the Israelites, that he calcined it and reduced it to powder, that he made these idolaters drink, to serve as a reproach for their sin. Now, there is no one who does not know that gold cannot be reduced to powder by calcination, unless this is done, or by immersive calcination, which is practiced by means of aqua regia, or by amalgamation, which is practiced by means of mercury, or by projection, which are three things which can only be understood by those who are consummate in the theory and practice of chemistry. Hippocrates even confirms this truth when he says in the Book of the Diet, Artifices aurum mali igni liquidant. Since all artists know that it takes a very violent fire to melt gold, and that moreover, fire would purify gold rather than destroy it, if it is not made treatable and volatile by means of some salts, or of some powders, which are known only to a few people, who have learned it by the work of chemistry alone. We could still bring back the authority of Aristotle, that his followers of today want to use to fight chemistry, who says that the people of Umbria calcined reeds to extract salt, which was for their ordinary use, what they could not do without chemistry, which had taught them the means, and which had made known to them, that salt was of an incorruptible nature, which could not perish by this simple calcination. If we run through all the centuries since the creation of the universe, we will not find any that has not provided some excellent man, who will have made himself recommendable to posterity by means of chemistry. Witness this Egyptian Mercury, called Trismegistus, that is to say, 3 times great, whose works still confuse the most learned of this century. Witness again the one who found the invention of glass, and this other much more praiseworthy than him, who had the secret of making it malleable, who nevertheless perished with his secret by the strange and tyrannical policy of the Emperor Tiberius. Democritus, Cleopatra, Zosime, Synesius, and many others of the same time, and after them Raymond Lully, Pierre Diapono, Basil Valentin, Isaac Hollandaise, and Paracelsus, prove by their excellent works, that chemistry is the true key to nature, that it is by means of it that the artist discovers his rarest beauties, and that without it no one will ever be able to achieve the true preparation of the remedies necessary for the cure of so many different diseases which afflict the human body every day. But it would be ungrateful to our century, to the memory of a very excellent and very charitable physician, and to the work of one of the most skillful and most curious artists who have ever been, not to name the deceased M. de Helmont and Mr. Glauber who still lives, since they are now like the 2 beacons that must be followed in order to understand the theory of chemistry well, and to practice its operations well. We will therefore draw from the works of Paracelsus, Helmont and Glauber. Division of this work. We will divide it into 2 parts. The first will deal with theory, and the second with practice. The first part will have 2 books, the first of which will treat of the principles and elements of natural things. The second will show the sources and the effects of the pure and the impure. The second part will also be divided into 2 books. The first will contain the terms necessary to do well and to understand well the operations of chemistry, to end with the last, in which we will give the means and the description to be able to anatomize the mixtures that plants, animals and minerals provide us with, in order to draw from it the remedies necessary for the cure of diseases. But before going into the matter, I have deemed it necessary to deal with a few questions which concern the nature of chemistry. Foreword, which contains several questions of the nature of chemistry. It is sometimes easy to treat and teach a science or an art, but it is not always easy to discuss it on principle. The first looks at the artist himself, whereas the second belongs to a higher and more elevated science, since there is only the first philosophy, which can make known with the required method, what must be the object, the end and the duty of science or art. We will therefore follow its rules in this foreword, which we will divide by questions, which will clarify in a few words most of the difficulties that arise on this matter. First question. Names given to chemistry. This science, like many others, has been given several names according to its various effects. The most common is that of chemistry, which draws its etymology, so it is said, from a Greek word which signifies juice, humor, or liquor, because one learns to reduce the most solid bodies to liquor, by chemical operations, or the preparation of gold and silver, according to Suedas. It is also given the name of alchemy, in imitation of the Arabs who add the particle al, which means God and great, when they want to express the excellence of something. Others have called it alchemy, presupposing that Ham, who was one of the sons of Noah, would have been after the flood the inventor and the restorer of the sciences and the arts, but mainly of metallurgy. Sometimes it is called spagyria, which declares its most noble operations, which are to separate and to join. And as its operations can only be carried out by the exterior fire which excites that of the interior of the mixtures, it is still given the name of pyrotechnics. That if it is called the art of Hermes or hermetics, this name testifies to its antiquity, as the name of distillery art signifies the most common of its operations. Of all these names, we will only use that of chemistry, as the most common and best known. Second question. Should chemistry be called art or science? And its definition. Before giving the definition of chemistry, it is necessary to seek its kind and its difference, since it is necessary to know these two things, in order to be able to give a true definition of them. It is therefore necessary to examine, if it is an art or a science, in order to have its genre, and to seek its difference in its object. It is even from this object that it must be drawn. But in order not to envelop this question in difficulties, let us say in a few words the difference which is between art and science, and how the word chemistry can be taken in many ways. The difference which is between art and science can be drawn from the difference of their ends. As science has only contemplation as its goal, and the end is only knowledge, with which it feeds and is satisfied, without going any further, in the same way art tends only to the only operation, and he does not stop operating until he has carried out what he set out to do. From which we can infer that science is properly only the examination of things which are not in our power, whereas art concerns itself with what is in our power. This being said, it should be known that as chemistry is of a very great extent, also it has several ends. In all the nature it has as its object, there are things which are completely under the power of its disciples, as there are others which are in no way subject to it. Besides these two sorts of subjects which are totally different, there is a third kind which are partly under their domination, and which are not also partly there. Which means that we can say that there are three kinds of chemistry. One, which is completely scientific and contemplative, can be called philosophical. Its aim is only the contemplation and the knowledge of nature and its effects, because it takes for its object things which are in no way in our power. The second kind of chemistry can be called iatrochemistry, which means chemical medicine, and which has for its goal only the operation, to which however it can only arrive by means of contemplative and scientific chemistry, because like medicine has two parts, theory and practice, and that this theory is only to arrive at practice. Thus this iatrochemistry also participates in one and the other, since it contemplates only to operate, and that it operates only to satisfy the minds of its disciples on the contemplation of things, both of those which are not, and of those which are in our power. The third kind is called pharmaceutical chemistry, which has only the operation as its goal, since the apothecary should only work according to the precepts and under the direction of the iatrochemist, whose true model we have in the person of Mrs. Vallet, chosen by His Most Christian Majesty for his first physician, who very eminently possesses the theory and practice of the three chemistries that we have described. This third chemistry has for its object the things which are subject to our power, to operate on them, and to draw from them the different parts which they contain. We can conclude from all that above, that chemistry can be called science and art, in view of the species it contains under itself, which makes me say that it can be called a practical science. After having found the genus, we must also find the difference, in order to give an exact definition. Some define chemistry, the art of transmutations, others, the art of separations, and still others, the art of transmutations and separations. But as transmutation and separation are effects of chemistry, therefore they cannot establish its specific and true difference. There are still several others who define it in various ways, all of which relate to the definitions we have reported. This is why we must necessarily take its difference from its object, as we have said above. Some authors give the mixed body as object to chemistry, but they are mistaken, because the elements which make simple bodies are also subject to this science. Others want it to be the natural body. These are also mistaken, since chemistry speaks and treats of the universal spirit, which is stripped of all corporeality. I therefore say that chemistry has for its object all the natural things which God created out of chaos. Note in passing that by natural things I mean not only the bodies which are said to be composed of matter and form, but also all created things, although deprived of all body. Thus the opposition of natural things to supernatural will put the difference between the Creator and the creatures, to erase the reproach which is made to those who make profession of this beautiful and noble science. This is why I define chemistry as a practical science, which works on natural things. It is science, as I have already said, because it not only contemplates natural things, but also because it passes from contemplation to operation. It's from that last part that it can be called a practical science. In a word, it is nothing other than physics itself, insofar as it puts its hand to work to examine all its propositions by reasonings which are founded on the senses, without be satisfied with a pure and simple contemplation. Here, then, is the difference between the chemical physicist and the speculative physicist. That is, if you ask the first what parts a body is composed of, he will not be satisfied with simply telling you, and satisfying your curiosity through your ears, but he will make you see and know it to your other senses by making you touch, feel and taste the parts that made up this body, because he knows that what remains after the resolution of the mixture was that which made its composition. But if you ask the speculative physicist what a body is made of, he will answer that this is not yet determined in the school, that if it is a body, it has quantity, and that consequently it must be divisible, that the body must therefore be composed of divisible things or indivisible, that is, of points or parts. Now it cannot be composed of points, since the point is indivisible, and has no quantity, and consequently it cannot communicate quantity to the body, since it does not itself have it, whence we conclude that it must be composed of divisible parts. But it will be objected to him, that if it is, that he has to mark whether the smallest part of this body is divisible or not. If it is divisible, it is not yet the smallest part, since it can be divided into other smaller ones, and if this smallest part is indivisible, it will always be the same difficulty, because it will be without quantity, so it will not be able to communicate it to the body, not having it itself. We know that divisibility is the essential property of quantity. You see that chemistry rejects speculative arguments of this nature, to attach itself to things which are visible and palpable, what we will show in the work, for if we tell you that such a body is composed of an acid spirit, of a bitter salt and of a sweet earth, we will make you see, touch, smell and taste the parts that we will draw from it, with all the conditions that we will have attributed to them. Third question. From the end of chemistry. We should not be surprised if ordinary physicists have found so few lights for the knowledge of natural bodies, since they have never had any other goal than the sole contemplation, not having believed that they were obliged to put their hands to work, to acquire a real knowledge of the mixtures by the stripping and the chemical anatomy. They and their followers imagined that it would be doing harm to their gravity to blacken their hands with coal, which the physicists and chemists did not apprehend, although they had contemplation for their object as well as they did. They believed that it was necessary to join the operation to it, in order to have an entire contentment, and to find stable and firm foundations to support their reasonings, not wanting to build on the ideas of the vain opinions, frivolous and fantastic, which made them take the expense, the trouble and the work in good faith, and they weren't put off by the vigils nor by the bad smells. But they have acquired a beautiful and complete knowledge of natural things. They have found by the experiences of their work, the causes of so many effects which are seen in the nature of things, what distinguishes them from empiricals, who confuse and mix all things without discernment and without any reasoning. Let us therefore say that the general end of chemistry is truly the operation, for the philosopher operates only to better contemplate, iatrochemistry also operates only to know by means of the operation, that which is done in the interior of the healthy man, so that he may be able to restore his health, when it is disturbed by disease. Finally, the pharmacist-chemist operates only to provide good and salutary remedies to the sick, according to the order he will receive from the learned and experienced physician. Is it any wonder then that chemists work with so much care to acquire this beautiful science, since it is impossible to become perfect in it without first having anatomized the greater part of natural things? As it is necessary to dissect the human body, to have the knowledge of its organizations, it is also necessary to open the composed things, to discover what nature has contained of most beautiful sounds their bark, from where it is easy to understand that it is impossible to become a good physicist if one does not acquire a perfect knowledge of all the parts of chemistry, and that a man cannot be a perfect doctor without having acquired this fine physics, since physics is the foundation of medicine, and that without it no one can attribute any title other than that of empirical. It is not enough to have parchment, seals, a cassock, nor to have taken one's degrees in some famous university. That does not belong, nor can it truly belong, except to one who has acquired a solid science, and who will have made himself a good practitioner by a long experience based on reasoning, with a mature and perfect judgment. From which two things flow: the first, that chemistry does not consist simply in knowing how to prepare a few remedies, as some people imagine, but that it consists principally in making good use of it with all the circumstances and dependencies of the theorems of this fine art, which is properly true medicine. The second, that he who uses chemical remedies, without having the true knowledge of his theory, can have no other name than that of empirical, since he is unaware of the internal efficient causes of their effects, and that he does not know the physical reasons which lead him to give such a remedy in such and such a disease, not having the funds to be able to know that these rare medicines never act by their primary or secondary qualities, but that they always act by virtues which are specific to them, as we will show it in the continuation of this treatise. First Part. Book First. First Chapter. Of the Universal Spirit. The title of this chapter shows that some erroneously maintain that the natural body is the only object of chemistry, since it treats of the universal spirit, which is a substance stripped of all corporeity. This is why we have given it with much more reason all natural things for its object, that is to say, all created things, both those which are corporeal and those spiritual, and the invisible as well as the visible, and this because chemistry not only shows how the body can be spiritualized, but it also shows how the spirit is embodied. For after having studied the anatomy of nature in general and in particular, after having searched and penetrated to its center, the chemistry has found the source and root of all things to be a spiritual, homogeneous and self-like substance, which ancient and modern philosophers have called by many different names. They called it vital substance, spirit of life, light, life balm, vital mumi, natural warmth, radical humidity, soul of the world, entelechy, nature, universal spirit, mercury of life. They also named it in many other ways, which it is useless to relate, since we have given the main names. But as we want to deal in this first book with the principles and elements of natural things, it is reasonable that we deal first with the first principle, of which the others are principled. Now this principle is nothing other than nature itself, or this universal spirit, with which we shall deal in this chapter. Paracelsus says in his Livre de Vexations, that domus est semper mortua, sed eam inhabitans vivit. He wants to show us by this comparison, that the force of nature is not in the body, mortal and corruptible, but that it we must seek in this marvelous seed, which is hidden under the shadow of the body, which has no virtue of itself, because all that it has and all that he can have, comes immediately from this seminal spirit which he contains in himself, which manifestly appears in the corruption of this body, during which his internal spirit forges a new one, or even several new bodies by the remnants of the first. This is what makes our German Trismegistus say again in the same place, that the force of death is effective, because then the spirit frees itself from the bonds of the body, in which it seemed to be as if without power. Since he was a prisoner and he begins to manifest his virtue, when it was believed that he could do less. The grain of wheat which rots in the ground proves this truth. It is by this rot that the body being opened, the internal seminal spirit which is enclosed within, pushes a pipe at the end of which it produces an ear furnished with several grains, which are totally similar to that which is lost and destroyed in the earth. This spiritual substance, which is the first and unique seed of all things, has three distinct and not different substances in itself, for it is homogeneous as we have said, but because there is in it a hot, a humid and a dry, and all three are distinct from each other, and not different. We say that the three are only one essence and the same radical substance. Otherwise, as nature is one, simple and homogeneous, there would however be found in nature nothing that was one, simple and homogeneous, because the seminal principles of these substances would be heterogeneous, which cannot be because of the great inconveniences that would follow, for if the hot were different from the moist, it could not be nourished by it, as it necessarily nourishes it, because food is not made from different things, but from similar things. If the food was in its beginning different from the nourished, it would have to strip itself of all necessity of this difference, before it could be its last food. Now, it is very certain that the humid radical is the last nourishment of natural heat, which means that it cannot be different from this heat. Moreover, if they remain different, each would want to produce its like, and thus this internal war would prevent the generation of the compound. Let us therefore conclude that this radical and fundamental substance of all things is truly unique in essence, but that it is triple in nomination, for because of its natural fire, it is called sulphur, because of its humidity, which is the own food of this fire, it is called mercury, finally, because of this dry radical, which is the cement and the bond of this humidity and this fire, it is called salt. What we will show more exactly, when we speak of these three principles in particular, and when we examine whether they can be transmuted into each other. After having thus spoken of the nature and the essence of this universal spirit, it is necessary that we examine what is its origin, and the effects which it produces. For the first, there can be no doubt that this spirit was created by the omnipotence of the first cause, when it caused this beautiful world to hatch out of nothingness, and lodged it in all parts of this great machine, as the poet very well recognized when he said, "The spirit within moves, and the mind, infused throughout the limbs, stirs the whole mass." Especially since all parts of this universe need its presence, as we notice by its effects, for if someone has been deprived of it, he does not fail to return to stay with her, in order to restore her life by his arrival. Thus we see that after having drawn from the vitriol many different substances which it contains, if we expose the dead head of this vitriol to the air, in some place which is covered from the injuries of the water, that this spirit does not fail to resume its place there, because it is powerfully attracted by this womb, which has no other greed than to replenish itself with this spirit, which is the one that makes up the best part of all beings. For as things exist only for their operations, they can also act only by their internal efficient principles. Now, like this universal spirit, it can only be specified by the means, particular ferments, which impress in it the character and the idea of the mixtures, to be made such or such determined beings, according to the diversity of the matrices, which receive this spirit to corporify it. Thus, in a vitriolic matrix, it becomes vitriol, in an arsenical matrix, it becomes arsenic, the vegetable matrix causes it to be a plant, and so with all the others. But notice two things here. The first, that when we say that this spirit is specified in such and such a matrix, that we do not want to hear anything else, except that this spirit has been embodied in such and such a compound, according to the diversity of the idea that he received by means of the particular ferment, and that nevertheless one can withdraw him from this compound, by stripping it, by means of art, of this gross body, to clothe it with a more subtle body, and thus bring it closer to its universality, and it is then that this spirit manifests its virtues much more eminently and more sensibly than it did. The second thing you have to notice is, that this mind cannot return to its first indifference, or to its first universality, until it has totally lost the idea it received from the womb, in which it was incorporated. I say that he must have completely lost this idea, because although these spirits have been decorporated by art, nevertheless they still preserve for some time the character of their first corporification, like that manifestly appears in an air plagued with realgaric and arsenical spirits, which flutter invisibly over everything. But when he has completely lost this idea, he then rejoins the universal spirit, if he nevertheless finds some fertile matrix, being still a little imprinted with his idea, then he corporifies himself into several different compounds, like this appears by plants and by animals, which we see being produced without apparent seed, such as mushrooms, nettles, mice, frogs, insects, and many other things that need not be reported. This is what we had to say concerning this universal spirit. We reserve the right to speak of the matrices which specify it, which embody it, and which communicate to it the idea and the character of such a determined being, when we will deal with the elements. Chapter 2. Of the various substances which are found after the resolution, and the anatomy of the compound. We can consider the principles and elements which constitute the compound, in three different ways, namely, either before its composition, or after its resolution, or when they still compose and constitute the mixture. We showed in the preceding chapter what was the nature of the principles, before they compose the mixture. It is necessary that we show in this second chapter what they are, after the resolution and during the composition, what we will treat only generally and succinctly, because we will talk about it more fully and in particular in the following chapters. We said above that the universal spirit, which radically contains in itself the first three substances, was indifferent to being made of all sorts of things, and that it was specified and embodied, according to the idea it took of the womb where he was received, that with minerals, it became mineral, that with vegetables, it became a plant, and that finally with animals, it became animal. We will speak below, and of this idea and of the matrices which communicated to it. During the composition of the mixed, this spirit retains the nature and the idea that it took in the matrix. Thus when he has taken the nature of sulphur, and imprinted it with his idea, he communicates to the compound all the virtues and all the qualities of sulphur. I say the same thing of salt and mercury, for if it is specified, or if it is only identified in one of these principles, it immediately makes it appear by its actions, thus things are fixed in their composition. And volatile, liquid or solid, pure or impure, dissolved or coagulated, and so with the others, depending on whether this spirit holds more or less of salt, sulphur or mercury, and depending on whether it holds more or less of the mixture of earthiness and the coarseness of the matrices. But after these principles are separated from each other, as well as from the earthiness and the corporeity that they have of their matrices, they show well by their powerful effects, that it is in this state that they must be reduced, if you want them to act effectively, although they still retain their character and their inner idea. Thus a few drops of spirit of wine will have a greater effect than a whole glass of this bodily liquor in which he was enclosed. Thus a drop of spirit vitriol will seem more effective than several ounces of body vitriol. But notice that these great virtues, and these great and powerful effects remain in these minds only as long as the idea of the mixture from which they were drawn, remains theirs, for as all things tend to their first principle. After having cleared up these things, we must see how many substances chemistry finds in the resolution of the compound, and what they are. Aristotle says that the resolution of things shows the principles that constitute them. It is on this same maxim that our science is founded, both because it is very true, and because chemistry accepts as principles of sensible things only what can be perceived by the senses. And as the anatomist of the human body has found a certain number of similar parts, which compose this body, at which he stops, chemistry similarly endeavors to discover the number of the first and similar substances of all the compounds, for the present to the senses, so that they may better judge of their offices, when they are still joined in the mixed, after having seen their effects and their virtues in this simplicity. And it is from there that the name of sensitive philosopher was given to the chemist. For as the anatomist uses razors and other sharp instruments, to make the separation of the different parts of the human body, which is his main purpose, so also does the chemical artist, who uses the instruction taken from nature itself, to achieve its end, which is none other than to assemble homogeneous things, and to separate heterogeneous things by means of heat. Because of itself it contributes nothing something other than his care and his pains, to govern the fire, as required by the natural agents and patients, in order to resolve the mixtures into their various substances, which he then separates and purifies. Principles of the resolution of bodies. After chemistry has worked on compounding itself, it finds in its last resolution 5 substances which it admits as principles and as elements, on which it establishes its doctrine, because it finds no heterogeneity in these 5 substances, which are phlegm or water, spirit or mercury, sulphur or oil, salt and earth. Some give them other names, for everyone is permitted to name them as he sees fit, since that is not of great importance, provided that we agree and that we can agree on the thing, without worrying about the name. Now, just as the integrity of the mixtures cannot subsist if we remove some of these parts from them, so the knowledge of these substances would be imperfect and defective if we separated them, because they must be considered both absolutely and respectively. 3 of these substances are presented to us by the aid of the chemical operation in the form of liquor, which are phlegm, spirit, and oil, and the 2 others in solid form, which make salt and earth. Phlegm and earth are usually and commonly called passive, material, and less effective principles than the other 3, but on the contrary, spirit, sulphur and salt are called active and formal principles, because of their penetrating and subtle virtue. Some call phlegm and earth elements. But if the definition which Aristotle gave to the principles is essential, to know that the principles nec ex aliis, nec ex esse in visum scient, experience shows us that these substances cannot properly be called principle, because we have said above that mercury is changed into sulphur, since the moist is the aliment of the hot, and the aliment is metamorphosed into the nourished. This is why the definition of element would rather suit these substances, since they are the last that are found after the resolution of the compound, and the elements are ea quae primo component mixium, and in quae ultimate resolvitur. But because the elements are considered in 2 ways, either as parts which compose the universe, or which compose only the mixed bodies, yet to accommodate us to the ordinary way of speaking, we will give them the name of principles, because they are constituent parts of the compound, and we will retain the name of element for these great and vast bodies, which are the general matrices of natural things. Chapter 3. Of each principle in particular. Section 1. To know if the 5 principles which remain after the resolution of the mixed, are natural or artificial. Chemistry receives as principles of the compound the 5 substances, of which we have spoken above. This source being quite sensitive, it reasons only on what the senses make it perceive, and this because after having made a very exact anatomy of a natural body, she finds nothing beyond that which does not correspond to one of these 5 substances. But here we can ask a question, which has no little difficulty, know, if these 5 substances are natural principles, or if they are artificial, and if they are not rather principles of destruction and disunity than principles of composition and mixing. One can answer that there is really difficulty to know if these principles are natural, because we do not see them coming out of the compound by a corruption, or by a natural putrefaction, but that it cannot be done only by an artificial corruption, which is practiced by means of the heat of fire. However, if we want to examine the thing closely, it will be found that we can in truth only extract these substances by means of the chemical art. They are nevertheless purely and simply natural, since everything that the art is to provide the vessels fit to receive them. Corruptio unius is gene ratio alterius, thus we feel something which strikes, or which even shocks our sense of smell in the natural putrefaction of things, which testifies that the air is full of volatile spirits, which are saline and sulphureous, by which the radical dissolution of the mixture takes place. Salt is resolved by means of phlegm, and as salt is the place of the 2 other principles, also, they can no longer subsist in the mixture, because the heat which accompanies all the putrefactions, the subtleties and carries them away if well, that we are left with only what is terrestrial in the compound. This is why we conclude that these principles, although made manifest and sensible by the operations of chemistry alone, nevertheless this does not prevent them from being natural. Because if nature had not housed them in all things, we could not draw the bodies indiscriminately from sounds as we can. Whence we draw this consequence, that it is not by transmutation that these substances come out of the mixture, but by a pure natural separation, aided by the heat of the vessels and the hand of the artist. All beings cannot be transformed indifferently and immediately into one and the same thing. This is why, it should not be found strange, when one draws other substances from these mixtures, when one works on them, by other means than by the separation of the principles, as are the quintessences, the mysteries, the magisteriums, specifics, tinctures, extracts, focules, balms, flowers, panaceas and elixirs, of which Paracelsus speaks in his books of the Orthodoxes. Since all these different preparations derive their various virtues from the diversity of the mixture of the principles, of which we shall speak in the following sections, according to the order that they first come to our senses, where we consider them as when they still compose the mixed, and as being separated from it. Second section. Phlegm. The name of phlegm is given to this insipid liquor, which is commonly called water, when it is separated from any other mixture. It is the first substance that appears to our eyes. When the fire acts on some mixture, we first see it in the form of vapor, and when it is condensed, it is reduced to liquor. Its presence is as useful in the composition of the mixture as that of any other principle. And we are not of the opinion of those who regard it as useless, but the proportion and harmony must remain within the limits required by the necessity of natural bodies, because the phlegm is like the curb of the spirits, it cuts down their acidity, it dissolves the salt and weakens its corroding acrimony, it prevents the inflammation of the sulphur, and finally serves to bind and mix the earth with the salts. For as these two substances are arid and friable, they could not give much firmness and solidity to the body without this liquor. Hence it causes corruption and dissolution by its absence, which causes some to call it the principle of destruction, for it evaporates easily, whence it happens that the mixture cannot remain long in the same state and in the same harmony, because this nascent part exhales easily and at any time, which makes it subject to the slightest injuries that occur, as much from internal causes as from external causes. This is why it is necessary that those who work for the conservation of the mixtures study to retain this principle in the compound, because it is it which retains all the others in check. It is so easy to extract that only a slow and moderate heat is needed to separate it from the other principles, as we see in the operations. It suffers from several alterations, which however do not change its nature, for if it appears to us in vapors, they are nevertheless essentially nothing other than phlegm itself, both by internal and external causes. This is why it is necessary that those who work for the conservation of the mixtures study to retain this principle in the compound, because it is it which retains all the others in check. It is so easy to extract that only a slow and moderate heat is needed to separate it from the other principles, as we see in the operations. It suffers from several alterations, which however do not change its nature, for if it appears to us in vapors, they are nevertheless essentially nothing other than phlegm itself, both by internal and external causes. This is why it is necessary that those who work for the conservation of the mixtures study to retain this principle in the compound, because it is it which retains all the others in check. It is so easy to extract that only a slow and moderate heat is needed to separate it from the other principles, as we see in the operations. It suffers from several alterations, which however do not change its nature, for if it appears to us in vapors, they are nevertheless essentially nothing other than phlegm itself. It is so easy to extract that only a slow and moderate heat is needed to separate it from the other principles, as we see in the operations. It suffers from several alterations, which however do not change its nature, for if it appears to us in vapors, they are nevertheless essentially nothing other than phlegm itself. It is so easy to extract that only a slow and moderate heat is needed to separate it from the other principles, as we see in the operations. It suffers from several alterations, which however do not change its nature, for if it appears to us in vapors, they are nevertheless essentially nothing other than phlegm itself. You will notice here that the vapors are of different nature, some are simply aqueous and phlegmatic, the others are spirituous and mercurial, the others sulphureous and oily, and there are still some others which are mixed together from the three preceding ones. It should also be observed that the same salts and mineral and metallic earths can be subtilized and reduced to vapors, which are still different from the four preceding ones, since fixed and heavy spirits and flowers result. We can very well refer to the whole doctrine of igneous, aqueous, or aerated meteors, unlike these exhalations and these vapors, because as we see that the aqueous vapors easily condense into water in the stills, which the spiritual or the oily ones do not, which require much more time and refreshment, we can also draw from this several consequences for medicine, and particularly for what concerns the pains, which are believed to come from vapors and exhalations, which are ordinarily called meteorisms of the ventricle and spleen, for the aqueous ones cannot cause so much distension, because they are more quickly compressed and condensed, than those which come from mixed spirits, oils and salts. Now, as too much phlegm extinguishes the natural heat, and slows down the body and all its actions, too little causes the body to be burnt or corroded, when sulphur, fixed spirit or salt gains the upper hand, which obviously proves. To conclude what we have said of this principle, you will observe that the phlegm of the mixed must ordinarily be the cleanest menses to draw from it the tincture and the extract, because it still retains some character of its compound and some idea of his virtue, but mainly because it is most often accompanied by the volatile spirit of the mixed, which makes it capable of penetrating it more easily and of extracting its virtue, especially since it is part of a mixed nature. Of a very subtle sulphur and mercury which comes closest to the universal. Section 3. Spirit. Some call mercury the second substance which appears to us when we anatomize the compound, others call it humid radical, but we will retain the name spirit, which is most in use. However, so that you do not deceive yourself in these vulgar appellations of principles, so that you do not confuse them with the compounds, it is necessary that you know that they were named in this way, only by the resemblance and the correspondence that they have with them. Do not therefore take the phlegm principally for pituite, neither mercury for quicksilver, nor sulphur for that vulgar sulphur which enters into the composition of gunpowder with saltpeter, nor salt for that common salt, which we put on our tables. And still less the earth bridge of the bowl of Armenia, or for sigillate earth, since all these things are bodies composed of these same principles, which we designate by these names. So these are common names, the idea of which we attach to particular substances. The spirit, therefore, is nothing other than this airy, subtle, penetrating and active substance, which we draw from the mixture by means of fire. From which it must be concluded that this principle is in itself one, simple and homogeneous, which has taken its idea of the character of its specific and particular matrix. Which we will elucidate below, when we deal with the elements and their virtues. Who took his idea of the character of his specific and particular matrix. Which we will elucidate below, when we deal with the elements and their virtues. Who took his idea of the character of his specific and particular matrix. Which we will elucidate below, when we deal with the elements and their virtues. Now, this substance is considered as still a component of the mixture, or as being separated from it. Out of the mixture this substance is extremely penetrating, it incises, it opens and attenuates the most solid and most fixed bodies. This spirit excites the heat in things by fermenting them, it loosens the bonds of sulfur and salt, and makes them separable, it resists rot, and yet it can produce it by accident. It devours the salt and unites itself so closely with it that you can hardly separate them except by the extreme violence of the fire. He has his warmth, as he also has his coldness, for it does not act through elementary qualities, but through those which are proper and specific to it. Finally, we still lack expression specific to his nature, since he is a true Protheus, which only works like the sun, which moistens and which dries, which whitens and which blackens, according to the diversity of the objects on which it acts. This same spirit communicates many fine qualities to the phlegm, for it prevents it from becoming corrupted, it makes it penetrating, and lends it almost all the activity it possesses. Phlegm also by a natural duty restrains the too great activity, and so to speak the fury of the mind, and makes it so treatable that it can be useful in an infinite number of ways. Now, while this spirit remains in harmony, and does not exceed the terms of its duty in the mixed, it renders them notable services, because it prevents the growth of excrement, and of any other substance contrary to the nature of the compound, and that it still multiplies and fortifies all its faculties, as much against animals, vegetables, as minerals. That if, on the contrary, this principle is constrained by some other agent, besides overriding the condition and constitution of its mixture, it then changes the entire economy of the compound, as we will show when we deal with the principles of destruction. Section 4. Sulphur. This principle has been called by many names, as well as the others, for it is given the name of oil, of natural fire, of light, of vital fire, of balm of life and of sulphur. Besides all these names, the artists have given it several others, with which we will not fill in this section. We will content ourselves, according to our custom, with examining the nature of things, and we will leave this fight to the ergotists. The substance which we will sometimes call sulphur and sometimes oil, is the third which we derive by the artificial resolution of the compound. We will name it thus, because it is an oleaginous substance which easily ignites, because it is of a combustible nature, and it is by means of it that the mixtures are rendered such. It is called principle as well as the others, because being separated from the compound, it is homogeneous in all its parts, as are the other principles. This substance is also considered in two ways, for when it is released from the others, it floats the phlegm and the spirits, because it is lighter and more airy, but when it is not absolutely detached from the salt and the earth, it can fall to the bottom, or swim in between, for the sulphur supports and sustains the earth and the salt, until it is completely vanquished by their weight. He does not readily receive the salt, unless he is previously allied with some spirit, or the salt has been circulated with the spirit, with which he has great sympathy, and it is then that they together receive the sulphur very easily, which is very remarkable, because without this knowledge one cannot make exactly the panaceas, the true magisteriums, the essences, the mysteries, nor the other remedies the most secret which are not of the district of medicine, any more than of the Galenic pharmacy. We know that those who are profession of this medicine, cannot account for the most beautiful effects of nature. This sulphur is the matter of the igneous meteors, which ignite in the various regions of the air, as well as of those which are seen in the places, where the minerals and the metals are engendered. It resists the cold and never freezes, for it is the first principle of heat. It does not suffer from corruption, it preserves the things which are put in its bosom, because it prevents the penetration of air, it softens the acrimony of salt, it coagulates and fixes itself by its means, it tames the acidity of spirits in such a way that even the most powerful etchings can do nothing on it, nor on the compounds in which it abounds. It helps to bind the earth, which is only powder, with the salt in the composition of the mixture. It also causes the binding of the other principles, because it tempers the dryness of the salt and the great fluidity of the spirit. Section 5. Salt. The phlegm, the spirit, and the sulphur are volatile principles which flee the fire, which causes them to rise and sublimate into vapors, which means that they could not give the mixture the firmness required for its duration, if it does not there were a few other fixed and permanent substances. There are two quite different from the others in the last resolution of the bodies. The first is a simple earth without any notable quality, except dryness and gravity. The second is a substance which resists fire and which dissolves in water, to which we have given the name of salt. These two substances which serve as the base and foundation of the mixture, although they are confounded by the action of fire, are nevertheless two different principles, in which we recognize differences so essential that there is no analogy between the two substances. 2. Salt makes itself manifest by its qualities which are innumerable, how full of efficacy they are, and much other than those of the earth, which is almost without power and without action in comparison with this other substance. Salt being exactly separated from the other principles, presents itself to us in a dry and friable body, which it is easy to put into powder, which testifies to its external dryness, but it is endowed with an interior humidity, as is proved by its melting. It is fixed and incombustible, that is to say, it resists the fire in which it is purified, it does not suffer from putrefaction, and can be preserved without being altered. This substance is esteemed by some, the first subject and the cause of all flavors, like sulphur that of odors, and mercury that of colors, but we will show the falsity of this opinion, when we treat of this matter. Salt dissolves easily in moisture, being dissolved, it supports the sulphur, and joins it by means of the spirit. It is useful for many things, for it causes the fire not to consume the oil as quickly as it would. This is why driftwood does not produce a long-lasting flame, because it is deprived of most of its salt. It is also salt that makes the earth fertile, because it serves as a vital balm with oil for plants, and from there comes that the grounds which are too washed of the rain, lose their fruitfulness. It is also used for the generation of the animals. It is still he who hardens the minerals, but to note that these effects only occur when it is in a just proportion, for too much prevents generation and growth. But lest you be deceived by the ambiguity of the word salt, you must know that there is a certain central salt, the root principle of all things, which is the first body with which the spirit is clothed. Universal, which contains in itself the other principles, which some have called hermetic salt, because of Hermes who, it is said, spoke of it first, but it can more legitimately be called hermaphroditic salt, because it partakes of all natures, and is indifferent to everything. This salt is the fundamental seed of all nature, with all the more reason, since it is the center where all the natural virtues lead, and the true seeds of things are only frozen, cooked and digested salt. Which seems true, in that if you boil any seed, you will make it sterile instantly, because this seminal virtue consists of a very subtle salt which dissolves in water, whence we learn that nature begins the production of all things with a central and radical salt, which she draws from the universal mind. The difference between these two salts is that the first engenders the other in the mixture, and the hermaphroditic salt is always a principle of life, and the other is sometimes a principle of death. But as we will deal below with the principles of is that the first engenders the other in the mixture, and that the hermaphroditic salt is always a principle of life, and that the other is sometimes a principle of death. But as we will deal below with the principles of is that the first engenders the other in the mixture, and that the hermaphroditic salt is always a principle of life, and that the other is sometimes a principle of death. But as we will deal below with the principles of death and destruction, we will not dwell here on the effects of one or the other, because the science of opposites being the same science, they will bring much more light, when they are respectively opposed. Sixth section. Of the earth. Earth is the last of the principles, as much of those which are volatile as of those which are fixed. It is a simple substance which is devoid of all manifest qualities, except dryness and restriction, for as regards gravity, we shall speak of it hereafter. I say manifest, because this earth still retains within itself the indelible character of the virtue it possessed, which is to embody and identify the universal spirit. The first idea it gives him is that of hermaphroditic salt, which by its action restores to this earth its first principles, so that the mixture is as if resuscitated, because one can still withdraw from this same body the same principles in kind, which had previously been separated by the chemical operation, as we will show below. Let us now consider the uses of this substance, which is very necessary in the mixture, since it is what increases the firmness of the compound, for when it is joined to salt, it causes corporeity, and consequently continuity of parts. Being mixed with oil, it gives tenacity, viscosity and slowness. It therefore gives with salt hardness and firmness, for as salt is its own crumbly substance, it could not unite intimately with the earth except by means of liquid substances to procure solidity. The inconveniences of this principle manifest themselves when the mixture requires the abundance of other substances, for if the earth predominates, it makes the body heavy, late, cold and stupid, according to the nature of the compounds in which it abounds. Note, however, in passing, that it is not the earth alone which causes the heaviness of the compound, as is maintained by certain philosophers, who walk more than they work, for one finds more earth in a pound of cork after its resolution, although it is a body which appears very light, than one will find in 3 or 4 pounds of gaiac or boxwood, which are such heavy woods, that water can hardly sustain them against the nature of other woods. From which we must necessarily conclude that the greatest heaviness comes from the salts and the spirits, which abound in these woods, of which the cork is deprived. We also see by experience that a vial full of vitriol spirit, or some other well-rectified acid spirit, will weigh more than 2 or 3 other vials of equal volume filled with water, or some other similar liquor. I know that people will object to me against this experiment, that the heaviness of the gaiac comes from its so compact substance, which leaves no entrance to the air, and that the lightness of the cork is caused by the great quantity of large pores and ample, which are filled with this light element, which causes it to swim on water, and the opposite is seen in gaiac and boxwood. But this answer does not satisfy the mind, for if lightness and heaviness are caused, one by rarefaction, and the other by condensation, it will be necessary that these pores which are in the cork, come from the abundance of the earth and the lack of other principles. From there we will conclude of necessity, first that the earth is porous by itself, and secondly, that it's her which makes bodies porous. Because nemo dat quod non habet, and propter quod unwinquod est tail, illa ipsum est magis, so say the Peripatetics, who are ambulatory philosophers, whence they will be compelled to confess by their own maxims, though it be nevertheless against their very principles, that the earth not only causes the lightness of the mixtures, but also that the earth is light of its own nature, which is a monster in their doctrine, and which is in fact contrary to experience, for there are no principles heavier than the earth, when they are artistically and duly separated from each other, for it always tends to the bottom of the vessel when they are mixed together. One must be nurtured in the study of a higher philosophy, to get out of this labyrinth, and become familiar with the beautiful Ariadne, who is nature itself, to obtain this thread which alone can rid us of so many detours. If we do it, it will not fail to make us see by the operations of chemistry, that there are two kinds of lightness and of heaviness, to know one which is interior, and the other which is exterior, that one is found in the principles, when they still compose the mixture, and the other, when they are separated from it. Chapter 4. Elements, both in general and in particular. Section 1. Elements in general. The difference which the Peripatetics put between the principle and the element, is that the principles cannot take the nature of one another, that they cannot be metamorphosed nor transmuted into each other, but that for the elements, they are substances, which are themselves composed of principles, and which compose after the mixtures, and that thus these substances can easily pass into the nature of one another. We will therefore examine below, whether this is true or not. But in chemistry, we take the elements for these four large bodies, which are like four matrices, which contain within them the virtues, the seeds, the characters, and the ideas that they receive from the universal spirit. Before, however, to enter into this kind of philosophy, it is necessary that after having spoken of the nature of the principles in the preceding chapter, we will deal with that of the elements in this one. We will first examine there if the Galenists are right to say that the mixtures are composed of these elements, and if there are not more substances in their resolutions than those of which they mention in their books. They say that one obviously discovers four different substances, when the wood is burned by fire, and assure that these are the four elements, which compose the mixture before its destruction. Let us examine if they have seen everything, and if they have deprived us of the care of looking for more. They probe their reasonings on the experience that follows. The four elements, they say, manifest to our senses, when wood is examined and consumed by fire, for the flame represents the fire, the smoke represents the air, the humidity which comes out through the extremities of the wood represents the water, and the ashes are none other than the earth. Whence they draw this conclusion, that since we only see these four substances, it was only they which composed the mixture. But although it is true that we perceive nothing else in this crude operation, however, if we take the trouble to do it more artistically, we will never fail to find something more in it. Container at the neck of this retort, if you then give a well-graduated fire, you will find two substances, which cannot come under our senses without this artifice, and it is on this that the Peripateticians and the chemical philosophers differ. This is why I find it necessary to harmonize them before going beyond. For this purpose let us admit to each other that the principles and the elements meet in the mixtures, but let us see in what way. When the former say that the smoke which comes out of burning wood represents the air, we say that they are right. It is only by a sort of resemblance that this smoke can be called air. It is therefore not air in effect, but it is so only by denomination, because experience shows that when this smoke is retained in a container, it has very different qualities from those of air, which leads to the conclusion that it can only be so called by analogy, and here is the difference which is between the one and the other concerning this substance. It is that the Peripatetics call it air, and chemists call it mercury. Let's discuss names, since we agree on the thing together. Let us come to the other element of the Peripatetics, which is fire, and to the other principle of the chemists, which is sulphur, and let us see in what they are different, and in what they agree. The former say that in the action which burns the wood, the fire manifests itself manifestly to our senses, but they are answered by this sensible experience, that what destroys the mixture cannot be a principle of composition, but that it is a principle of destruction, that if they say that the fire is not actually in the mixture, but that it is there only potentially, it is precisely on this point that I want them to agree with the chemists, who call sulphur, this potential fire Peripatetics. I therefore decide their dispute, by saying that the fire which we see coming out of burning wood is nothing other than the sulphur of fired wood, because the action of sulphur consists in its ignition. As for taking the ashes for the element of the earth, the salt which is drawn from these ashes by leaching, must persuade these philosophers, that the chemists have as much or more right than them, in the establishment of the number of their principles. After having clarified these matters concerning the number of principles and elements which enter into the composition of the mixture, we must say something of the number and properties of the elements, before speaking of each of them in particular, as well as of their matrices and their fruits. It is a rather surprising thing, that the followers of Aristotle have not yet agreed on the number of the elements, during the long time that his works have been in credit, for some of them rightly affirm that there is no elemental fire. I say with reason, when taken in the way they understand it, For what is the use of admitting an element of fire under the heaven of the moon, since it is given no other use than that to enter into the composition of the mixed, and that besides that this element is very distant from the place where the mixtures are made, we have found moreover, that the fire of the mixtures is nothing other than the sulphur of the compound. This is why, I conclude here with Paracelsus, that there is no other elementary fire than the sky itself and its light. As regards the various properties of the elements, we first ask if they are pure, and secondly, if they can be changed from one to another. As to their purity, I say that if they were such, they would be absolutely useless, for a pure land would be sterile, since it would have in itself no seed of fertility. The saltiness of the sea and the various qualities of the air also bear witness to what I say. But with regard to their mutual changes, they are not so easy as common philosophy has imagined, although they are not absolutely impossible, for it teaches that the earth changes into water, the water into air, the air on fire, and finally that the fire becomes earth again by other changes, because even the earth or the water sometimes take the form of vapors and exhalations. However, these vapors are always essentially earth or water, as is seen by the return of these vapors to their first nature. This change can therefore only be made in the event that such and such an element, having become completely spiritualized, comes to leave its elementary idea, and that afterwards it joins up with the universal spirit, which will then restore to it idea of another element, of which it would have the body, by the character that the matrix would give it. It is for this reason that chemists give two natures to the elements, when they speak of them, one which is spiritual, and the other which is corporeal, the virtue of one being hidden in the bosom of the other. This is why, when they want to have something that acts effectively, they try, as much as art can allow, to strip it of its body and make it spiritual. For as nature can communicate its treasures to us only under the shadow of the body, we can also do nothing but strip them of the coarsest of this body by means of art, to apply them to our use, for if we push them further, and spiritualize them in such a way, that they are no longer visible or perceptible to us, they have then lost the character and the idea of the body. These are the true effects of the elements, which are, as we have said, to corporify and to identify the universal spirit, by the various ferments which are contained in their particular matrices, and to give it the characters, which are engraved in them, for, as we have said, this spirit is indifferent to everything, and can be done everything in all things. Which happens, because nature is never idle, and acts perpetually, and that as it is a finite essence, also it cannot create nor destroy any being. We know that creation and destruction require infinite power. But as this discourse is too long, we will postpone it to the following sections, where we will deal with particular elements. Second section. Of the fire element. Since all things tend to their natural place and to their center, it is a manifest sign that they are carried there and attracted by a virtue of their own which they hide under the shadow of their bodies. This virtue cannot be anything other than the magnetic faculty that each element possesses, of attracting its like and repelling its opposite, for as the magnet attracts iron on one side, and drives it out on the other, the elements likewise attract by a similar virtue the things which are of their correspondence, and drive out and remove from them those which are of a nature different from theirs. Thus, since the fire rises upwards, there can be no doubt that this effect comes from what it tends towards its natural place, which is the elementary fire, where it is carried by its own spirit, when it emerges from the trade in other elements. In order to understand this doctrine well, one must first know that the element of fire is not enclosed under the sky of the moon, as we have said above, and that thus one cannot admit any other fire than the sky itself, which has its matrices, and its fruits like the other elements. For the great number of various stars which we see wandering in this vast element, are nothing else than particular matrices, where the universal spirit takes a very perfect idea before corporifying itself in the matrices of the other elements, and it is from there that one can easily understand the maxim of this great philosopher, which many conceive only as a chimera, namely, that nihil est inferius, quod non sic superius, and vice versa, and that of Paracelsus, who asserts that each thing has its star or its sky. Indeed, the virtue of things comes from the heavens, by the force of this spirit of which we have spoken so much to you. Paracelsus calls pyromancy the knowledge of this doctrine, and mainly when he dealt with the theory of diseases. For we see that the elements are like the domiciles of things which have some knowledge, either intellective, or sensitive, or vegetative, or even mineral, which some call the fruits of the elements. There must be no doubt, according to these maxims, that as the heavens are very perfect and very spiritual, they are also the abode of those spiritual and perfect substances which are called intelligences. But notice, that when I said that the fire emerges from the commerce of the other elements, when it rises above, I only spoke of the visible fire, which we use in our homes, which is not in effect that a meteor, or else a body imperfectly mixed with some elements, or some principles, in which fire or sulphur predominate, that the flame is nothing else than an oily and sulphurous smoke, which is ignited. And when the fire is made spiritualized by this release, it does not cease until it has returned to its natural place, which must necessarily be above and above the air, since we see that it is in a perpetual action in the air itself, in order to abandon it. It is also by means of this fire, which at all times seeks to return to its center, that the clouds which are hot and humid vapors, or meteors which are composed of fire or water, rise up to the second region of the air, where the fire leaves the water to rise higher, and thus the water no longer having that fire which sustained it in the form of vapor, and coming to thicken, is forced to fall back in the form of rain. Notice here the circle which nature makes, by means of that universal spirit which we have described, for as its power is limited, and it does not create or produce anything new, so it cannot create or destroy any substance. For example, the continual influences of the sky and its stars, incessantly produce fire or spiritual light, which begins to corporify first in the air, where it takes on the idea of hermaphrodite salt, which then falls into water and into the earth, where it takes on the body of mineral, vegetable or animal, by the character and effectiveness of a particular matrix, which is imprinted on it by the action of the ferment, and when this body dissolves by means of some powerful agent, its sulphur, its fire or the corporified light becomes purified in a way, that the stars attract it for their nourishment, because the stars are nothing else than a fire, a sulphur, or an activated light which is very pure. It is the same with the wick of the lamp, which being lit continually attracts and raises the oil for the maintenance of its flame. The stars attract this fire in the same way, which is purified by this action, and spiritualize it again to influence it again and to return it to the air, to the water and to the earth, which recorporify it. Thus you see that nothing is lost in nature, which is maintained by these two principal actions, which are to spiritualize in order to corporify, and to corporify in order to spiritualize. This is what we have already said, and they are like two ladders by which the influences descend downwards, and which then go up, for without this circulation the virtues of both would not last so long, and would be daily exhausted by the perpetual sending forth of so many fertilities, unless we admitted without necessity a continual creation and destruction of sublunary substances, which would establish new miracles. And as is ordinary, it could be called miracle without miracle, which would be a manifest contradiction. What source do you think can provide material for this great conflagration of Mount Jibal, which has lasted for so many centuries, without this circulation of nature? And who would have been making the mineral springs, which are hot and acid, flow for so long, if not by means of these admirable ladders? This is why we must not believe that it is impossible to be able to make a whole body pass into a spirit, and then put this same spirit back into a body. You know that art applying the agent to the patient, can do in a short time what nature could not do in a very long interval, and because the artificial circulation, which was done in an ancient sepulchre which was open to Padua in the 14th century, represents quite well the natural circulation, of which we have spoken, it will be very fitting to relate the story in a few words. Appian says in his book of Antiquities, that a very ancient monument was found in the city of Padua, in which was seen, after having opened it, a burning lamp, which had been lit several centuries before, as evidenced by the inscriptions of this monument. Now this could only be done by means of circulation, as it is easy to conjecture. It was necessary that the oil which was spiritualized by the heat of the fiery wick in this urn, condensed at the top and that it fell afterwards in the same place from which it had been raised. The wick could be made of gold, of talc, or of feather alum, which are incombustible, and this urn was so exactly and so justly closed, that the least particle of the oily vapors cannot escape. Section 3. From the element of air. The philosophers doubted for a very long time if there was an air, and if this space in which the animals roam was not empty of all substance. But the use of bellows, and the necessity of respiration, have finally abolished this error. This is why the chemists and the peripateticians have no dispute between them on the existence and the place of this element, but they are not in agreement on its uses, for the latter bring air into the composition of the mixtures, which the former absolutely deny, because it does not fall within their meaning in the final resolution of the compound. The main use that chemists give to this element is to make it serve as a matrix for the universal spirit, and it is in this matrix that it begins to take on some corporeal idea, before corporifying completely in the elements of water and earth which produce the mixtures which are the fruits of the elements. And because we see no element that does not produce its fruits, some have meant that the birds were the fruits of the air, but wrongly, for although these animals are volatile, yet they cannot do without the earth for their generation, nor for their food. Those who maintain that the meteors are the true fruits of the air, have much more reason, since it is in the region of the air that they take their true meteoric idea. Some have meant that the birds were the fruits of the air, but wrongly, for although these animals are volatile, yet they cannot do without the earth for their generation, nor for their food. Those who maintain that the meteors are the true fruits of the air, have much more reason, since it is in the region of the air that they take their true meteoric idea. Some have meant that the birds were the fruits of the air, but wrongly, for although these animals are volatile, yet they cannot do without the earth for their generation, nor for their food. Those who maintain that the meteors are the true fruits of the air, have much more reason, since it is in the region of the air that they take their true meteoric idea. Some call chromancy the doctrine and knowledge of the nature of this element, of its effects and of its fruits, but it must be called romance, for chromancy is something more universal and more general, since it is the science of chaos, that is to say, of this very great womb from which the Creator drew all the elements. It is the hustle and bustle or hyle of the Kabbalists, which is called water in the Scripture holy, when it is said that the Spirit of God brooded over the waters, Spiritus Domini incubat aquis. But one can ask here, if what we said above is true, knew that the elements can only very hardly leave their nature to clothe themselves with that of another element. How do you say that the air is the food of the fire, and that it is indeed so necessary to it, that it goes out as soon as the passage of the air is closed to it? The answer is easy. As we have already shown that the fire in our hearths is not pure, since the lighted matter throws out a quantity of fumes and sooty excrement, which harm the maintenance of the fire, this is why it needs a continual air, which removes all this sooty matter, otherwise it would smother the flame. So you see in what sense one must take this conversion, or this imaginary nourishment, and even in what true philosophy differs from false. We can still ask a question concerning the breathing of animals, whether the air they breathe serves them purely and simply as refreshment, as the philosophers commonly say, who are content to know what their masters give them, have taught, and who for any reason assert their authority. But those who examine the thing more closely, say that this air has still another use, which is much more excellent and more necessary, which is to attract by this means the universal spirit, which the heavens flow into the soul. Air, where it is endowed with an entirely celestial idea, entirely spiritual and filled with efficacy and virtue, it is metamorphosed in the heart into an animal spirit, where it receives a perfect and vivifying idea, which enables the animal to exercise by means of it all the functions of life, for this spirit which is in the air which we breathe, subtilizes and volatilizes all that there may be of superfluities in the blood of the veins and arteries, which are the store and matter of vital and animal spirits. It is by the strength and virtue of this spirit, that nature rids herself of the filth of food, which passes even into the last digestions, by the perspiration which she continually makes through the pores. It appears even in plants, though rather obscurely, for even though they have no lungs, nor any other organ for respiration, nevertheless they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, such as nourishing themselves, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated, which pass down to the last digestions, by the perspiration which it continually makes through the pores. It appears even in plants, though rather obscurely, for even though they have no lungs, nor any other organ for respiration, nevertheless they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, such as nourishing themselves, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated, which pass down to the last digestions, by the perspiration which it continually makes through the pores. It appears even in plants, though rather obscurely, for even though they have no lungs, nor any other organ for respiration, nevertheless they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, such as nourishing themselves, growing and generating, which is evidently seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated. It appears even in plants, though rather obscurely, for even though they have no lungs, nor any other organ for respiration, nevertheless they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, such as nourishing themselves, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated. It appears even in plants, though rather obscurely, for even though they have no lungs, nor any other organ for respiration, nevertheless they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, such as nourishing themselves, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated. However, they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, like nourishing, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated. However, they do not fail to have something analogous, which is their attracting magnet, which some call their magnetism, by which they attract this spirit which is in the air, without which they could not carry out their operations, like nourishing, growing and generating, which is clearly seen. When they are covered with earth, then they are deprived of the means of attracting this vivifying spirit which animates them, which causes them to die immediately as if suffocated. Section 4. Of the element of water. The most skillful and the most enlightened of the ancient philosophers believed that water was the first principle of all things, because it could engender the other elements, according to their opinion, by its rarefaction or by its condensation. But as we have shown that this change is impossible, we must therefore philosophize in another way. We do not consider in this place water as a principle which constitutes and which composes the mixture, for we have spoken of it according to this sense, when we have dealt with phlegm, but we will speak of it as a vast element which contributes to the composition of this universe, which contains in itself a large quantity of particular matrices, which produce a beautiful and pleasant diversity of fruits. First of all animals, which are fish, and all kinds of aquatic insects. Secondly, plants, such as duckweed, whose root is in the water itself, and finally animals, such as shells, pearls and the salt it carries in abundance in the earth for the production of the fruits of this element. Water is therefore the second general matrix, where the universal spirit takes the idea of salt, which is sent to it from the air, which has received it from the light and from the heavens, for the production of all things. Sublunaris. Paracelsus calls the science of water hydromancy. Water is therefore the second general matrix, where the universal spirit takes the idea of salt, which is sent to it from the air, which has received it from the light and from the heavens, for the production of all things. Sublunaris. Paracelsus calls the science of water hydromancy. Water is therefore the second general matrix, where the universal spirit takes the idea of salt, which is sent to it from the air, which has received it from the light and from the heavens, for the production of all things. Sublunaris. Paracelsus calls the science of water hydromancy. Section 5. From the element of earth. We spoke in the last section of the preceding chapter, of the earth, as of a principle which formed part of the mixture of the compound, and which one saw after its last resolution, but it is necessary that we treat of it here as of the fourth and of the last element of this universe. The earth is, in this respect, like the center of the world, to which end all its virtues, its properties and its powers. It even seems that all the other elements were created for the usefulness of the earth, for what is most exquisite in them is for its service. Thus heaven is incessantly running to furnish it with the spirit of life, for the expense and for the upkeep of his family. The air is in a perpetual movement to penetrate it to the deepest of its parts, and that to provide it with the same spirit of life that it received from heaven. And the water never rests to imbibe it, and to communicate to him what the air gives him. So much so that everything works for the earth, and the earth also works only for its fruits, which are its children, since it is the mother of all things. Now the first body that the universal spirit takes is that of hermaphroditic salt, of which we have spoken above, which generally contains in itself all the principles of life. It is not deprived of sulphur or mercury, for it is the seed of all things, which then corporify, and take on the idea and the quality of the mixtures by virtue of the characteristics of the particular matrices, which are enclosed within the interior of this great element. If it encounters a vitriolic matrix, it becomes vitriol. In that of sulphur, it becomes sulphur, and so with the others, and that by the efficacy of the various natural fermentations. In the vegetable matrix, it becomes a plant. In a mineral, it becomes stone, mineral and metal, and in the animal, living or non-living, he produces an animal, produced by the corruption of some animal or some other mixture. Bees, for example, are begotten from bulls, and worms from the corruption of several fruits. Now, as there are a great number of different mixtures, there is also a great variety of particular matrices, which causes often transplants into all things, but that concerns more chemical physiology than that of this course, where we treat things only generally, because we do not have time to particularize them. We call geomancy the particular science of this element and its fruits. We have by this science the knowledge of what nature operates, both in its entrails and on its surface. Its fruits are animals, vegetables and minerals. If these mixtures are composed of the purest principles of life, then they are of long duration, according to the nature and their condition, and can reach the end of their natural predestination, unless some external occasional cause causes them prevent them from going to the end of their career. But when chance mixes in their first composition, or in their food, someone with the principles of death or destruction, they cannot subsist for long, and cannot complete the career they had to fill. Chapter 5. Principles of Destruction. Section 1. Of the order of this chapter. As we have to deal with the pure and the impure, in the book which will follow this chapter, and as the principles of death are in some way contained under this genre, I also find it very appropriate to end this first book with the discourse of these principles, although they should not, properly speaking, be qualified by this name, for the principles must always compose, and must never destroy. We have shown that the principle could be considered in three ways, namely, either before the composition of the mixture, or during the composition, or finally after its dissolution and destruction. We can say here of the principles of death what we have already said of the principles of life. But because the opposites are more apparent, and make the difference in their nature better known, when they are opposed to each other, we will say something more succinctly of the principles of life before the composition of the mixture, in order to make better known the condition of the principles of death, when we speak of them in the third section, because we reserve to speak of their effects, when they are already embodied in the mixtures, when we will deal with the pure and the impure. Second section. Principles of life before composition. We have often said that the universal spirit, which is indifferent to becoming a particular being, is determined only by the character of the matrices into which it insinuates itself, and inasmuch as each element is filled with these matrices, each of them also contributes something of its own for the perfection of the compound. Heaven communicates to it through its stars, its celestial, spiritual and invisible virtue, which it sends into the air, where it begins to corporify itself in some way. The air then sends it into the water or into the earth, where it operates and binds itself to the matrix to form a body, by means of the various natural fermentations, which cause changes in things. Because this spirit is the true agent and the true internal efficient cause of these fermentations, which take place in matter, which of itself is purely passive, especially since this spirit is its archeum and general manager. Because when it is mixed and united in the body which covers it under its bark, it cannot manifest, nor produce the marvelous effects that it conceals in itself, because it is imprisoned, and it will never be able to exercise, nor to show his virtues, if he is not first delivered from the bonds of corporeality and the coarseness of matter. This is therefore what chemistry works with so much pains, care and study, to make known the beautiful truths of this natural science. And that he will never be able to exercise, nor show his virtues, if he is not first delivered from the bonds of corporeity and the coarseness of matter. This is therefore what chemistry works with so much pains, care and study, to make known the beautiful truths of this natural science. And that he will never be able to exercise, nor show his virtues, if he is not first delivered from the bonds of corporeity and the coarseness of matter. This is therefore what chemistry works with so much pains, care and study, to make known the beautiful truths of this natural science. Now, as this universal spirit is the first principle of all things, as everything comes from it, and everything returns to it, this obviously proves that it must necessarily be the first principle of the life and death of all beings, which entails no contradiction, because this is done in various respects. As the diversity of compounds requires a diversity of substances for their maintenance, there is also a diversity of matrices in the elements to manufacture these various substances, and it is from this that proceeds that which serves the life of the one, is very often the destruction and the death of the other. For example, a corrosive principle will be the death of a soft mixture, and on the contrary the soft principle will be the death of the corrosive, since it removes its acrimony, which constituted its essence and its difference. But speaking absolutely, it seems that this first principle, ideified in such and such a way, cannot be called the principle of life or of death. It can only be said respectively, with regard to such and such a mixture. But because the greater part of sweet things serve for the maintenance of man, because they are according to his taste, and because they participate in more than a few substances which are analogous to his nature, it happened from there that when the universal spirit is determined with this softness, it then takes the name of principle of life, as, on the contrary, it takes that of the principle of death, if it is attached to a corrosive idea, which harms not only the actions of man, but which similarly harms those of the mixtures, which serve for his food, and whose he draws his sustenance. Thus it happens that the air is filled with arsenical, realgaric and corrosive influences and vapors, which often cause the death of men by the necessity of respiration. However, as these minds are not influenced to this design, and this is only done by pure accident, also they cannot absolutely be called principles of death, since they are sent by nature for the generation and maintenance of arsenics, realgars and other corrosive mixtures, which belong to the sublunary beings, as well as man, and which were created by the wisdom of the sovereign master of the universe for a better end, although many do not recognize it, for nature and art make use of these mixtures and render them useful to man. So you don't have to call nature for that, stepmother towards man, since God gave him the means and the knowledge to be able to avoid these bad and malignant influences. So to accommodate ourselves to the ordinary way of speaking, we will say that the principles of life are nothing else before the composition of the mixture, than the universal spirit, insofar as it will have taken the idea of the principles benign in nature, human, and that it will carry in the center of its hermaphrodite salt, a moderate sulphur, a temperate mercury, and a soft salt, and on the contrary the principles of death are only this same spirit, which carries in its same hermaphrodite salt an acrid sulphur, a biting mercury, and a corrosive salt, as we will say in the following section. So to accommodate ourselves to the ordinary way of speaking, we will say that the principles of life are nothing else before the composition of the mixture, than the universal spirit, insofar as it will have taken the idea of the principles benign in nature, human, and that it will carry in the center of its hermaphrodite salt, a moderate sulphur, a temperate mercury, and a soft salt, and on the contrary the principles of death are only this same spirit, which carries in its same hermaphrodite salt an acrid sulphur, a biting mercury, and a corrosive salt, as we will say in the next section. So to accommodate ourselves to the ordinary way of speaking, we will say that the principles of life are nothing else before the composition of the mixture, than the universal spirit, insofar as it will have taken the idea of the principles benign in nature, human, and that it will carry in the center of its hermaphrodite salt, a moderate sulphur, a temperate mercury, and a soft salt, and on the contrary the principles of death are only this same spirit, which carries in its same hermaphrodite salt an acrid sulphur, a biting mercury, and a corrosive salt, as we will say in the next section. And that it will carry in the center of its hermaphroditic salt, a moderate sulphur, a temperate mercury, and a soft salt, and on the contrary the principles of death are only this same spirit, which carries in its same hermaphrodite salt an acrid sulphur, a biting mercury, and a corrosive salt, as we will say in the next section. And that it will carry in the center of its hermaphroditic salt, a moderate sulphur, a temperate mercury, and a soft salt, and on the contrary the principles of death are only this same spirit, which carries in its same hermaphrodite salt an acrid sulphur, a biting mercury, and a corrosive salt, as we will say in the next section. Section 3. Principles of death. I repeat once more, that when we say that these principles are against nature, we do not mean nature in general, but we mean only human nature, because it often happens that what is poisonous to one species serves as food for another, thus the hemlock feeds the starlings, and kills the men. This established maxim, I say that all heat, or rather than all hot, acrid, biting and corrosive substance, which destroys and consumes, is such, because it contains in itself an unnatural sulphur, and because it is of this sulphur that derives, as from their source, all the properties and virtues of the mixture, where this impure sulphur predominates. If life draws its source from a temperate, soft, natural and vital sulphur, if this life is followed by a long preservation by the essential properties of this sulphur, we must necessarily conclude from this that he who is of an opposite nature must be followed by death and destruction. All arsenics, realgars, stonecrops, sandarachs, and all other hot poisons of an igneous nature, whether celestial or aerial, aquatic or terrestrial. Our goal is not to speak here of the principles, which are contrary to human nature, when they are already embodied, and when they compose one of these venomous mixtures, because we reserve to explain ourselves in the next book. We will deal here with these principles only in so far as they are still spiritual, and as they descend from the stars by means of the universal spirit. Although this principle is unique in this respect, it nevertheless has three different denominations. We have already noted that sulphur, that is to say the hot, cannot be without mercury, which is the humid, nor without salt, which serves as a bond between one and the other. It follows that a biting mercury is needed, and a corrosive and caustic salt for the sustenance of a sulphur which is acrid. Likewise a temperate mercury and a mild salt are necessary for the preservation of a moderate sulphur. These three principles are always united and joined very closely together, whether they are considered as principles of life, or as principles of death. If we sometimes speak of them separately, it is only to make their nature and effects better understood, because there is always one of these principles, which makes itself superior to the others, and which makes its actions manifest, hiding and sealing the effects and the virtue of the other two, although they do not fail to act by their union with the one who predominates. For example, when the mercury of death acts, the sulphur against nature and the corrosive salt do not cease yet not their action, a potiori sumater denominatio. Now, just as the sulphur of death manifests itself in arsenics, realgars, stonecrops, and the mercury of death also manifests itself in all narcotics, and it is not without reason that we have said that these poisons were not only terrestrial, but that they were also aerial, for there is much of this malignant mercury in all the elements, which is not yet specified in no individual, but which flutters and which remains volatile, and when it overflows, it causes an infinite number of epidemic, pestilential and contagious diseases. That if the venoms, which are individuated, and which are already embodied, did not attract it for their nourishment, this would cause great damage and great disorder in the world. Now, as salt is the principle which causes corporification in all things, and as it is it which renders sulphur and mercury visible and palpable, because of the alloy which it makes of them, the corrosive salt also corporifies the two other principles of death, and makes them visible by means of the body which it gives them. Otherwise these substances would remain invisible in the universal spirit, if they were not made visible and corporeal by the action of salt, and it is by this means that we find true the so important maxim of this great philosopher, who says that, quod est occultum, sit manifestum, and vice versa. The violence and the malignity of this salt of death hardly manifests itself visibly in natural things, but when art has worked on one or more mixtures, it is then that the action appears, as is seen in sublimated corrosives, in strong waters, in antimony butter and in several other things, which are of this nature. It is by means of a salt of a seemingly natural nature that cancers, gangrene, scrofula, and all other gnawing ulcers, are engendered in man, which is against the feeling of those who accuse of these faults. Acrid and biting humors, which have only a chimerical foundation in the nature of things, as we will show in the following book, where we will show by what route these principles of death enter man. End of the first book. Book second. Pure and impure. First chapter. What is pure or impure? The words pure and impure can be taken in various ways, for some mean by the pure, what is useful and profitable to man, and by the impure, which is harmful to him. Others want what is homogeneous to be pure, and what is heterogeneous to be impure, but it may be that the heterogeneous will be profitable, and the homogeneous will be harmful. We can gather from this that nothing can be said to be pure or impure, speaking absolutely, and that this can only be said by comparison of one thing to another. Because, as we have already noted above, it may be that what is harmful to one may benefit another. For example, would it not be a very absurd opinion to believe that the bones of animals were impure because men did not eat them? We will not take here the pure or the impure according to these ideas, but we will understand by the pure, all that in the mixture can serve our goal and our design, as on the contrary, we will understand by the impure, all that is opposed to our intention. For though there are many parts in the mixtures which are injurious to man, yet speaking absolutely or respectively, with respect to the same mixture, the parts of this compound cannot be said to be impure, seeing that they are of the essence of this mixture, or that they constitute its integrity. Moreover, these parts can only be harmful to man conditionally, since nothing obliges him to use them. The pure and the impure are considered in this sense, either in man or outside of man. The impure that is in man disturbs and prevents his intention, which is to enjoy full and entire health without any interruption, what he also does outside of man, since we posit that it must necessarily enter into it. Here then is the difference which is between one and the other of these impure, it is that of the interior acts immediately by its presence, and that the other is considered only as absent, which however must be present some day, because, as man necessarily needs to breathe and to eat, also it cannot escape the action of impure, which is found in the air and in food, as we will see below. So that we will show that what some call the pure, nevertheless still contains in itself many impurities. Chapter 2. How the pure and the impure enter into all things. There is a salt, a sulphur, and a mercury in each mixture, as we have said above. Now any mixture which is perfectly composed, is either animal, or vegetable, or mineral. From there we gather, that as some serve as food for others, which appears by the change of minerals into plants, and plants into animals, and even animals into plants and minerals, also there is in each mixture, a salt, a sulphur and a mercury, which is animal, vegetable and mineral, which comes to them from the universal spirit. For everything that is nourished by its similar, and the dissimilar is driven out like excrement, that if the expulsive faculty is not powerful enough for this effect, there remains much excrement in the compounds, which causes many mineral diseases in man. Now what I am saying is done in this way. When food has entered man, and digestion has made the separation of the different parts of the mixtures which are used for his food, then each part draws from this food and from its animal principles, which is analogous and proper to each of them. But as regards the other principles, which cannot be made similar to our substance, and which do not substant our life, nature drives them out by the service extended to it by the expelling faculty. But if this servant is weakened, or overloaded by some occasional external cause, or by some internal disorder of the archaea, director of our life and our health, then these excrements coagulate, or volatilize according to the idea which they take by natural fermentation. Which means that these diseases can only be driven out by those who first know well the nature of the vice of the ferment, and secondly, who also know the proper and specific remedy, which can restore our nature, and which can appease the irritations of the spirits, which are ordinarily caused by bad fermentation. For if the ferment or the leaven is coagulative, it is necessary to know a specific solvent, which does not injure the ventricle, that if it is dissolving, and that it makes a bad collision of food and parts, it is also necessary that whoever wants to heal, knows the remedy capable of repairing this defect and correcting this disorder. It is from this that the redoubled fevers and the continuation of the attacks come, notwithstanding the use of many remedies, which cannot prevent them. If we had the time to expand here on several questions, which are beautiful and curious, this philosophy would also teach us the cause of several effects that men ignore. I will, however, give a sample of it in passing, on the question which is usually asked, know why men were much more robust, and lived without comparison much longer before the deluge, than after this universal inundation. We can give two reasons, or mark two causes for this effect and this marvelous change, according to what we have said above. The first is, that as the world was in its beginning, so there was as yet no alteration or change in things. This alteration is no virtue, only by the various mixtures and by the various mutations which have been introduced into the compounds, as a result of the curse which sin merited. The second reason derives from the fact that the waters, which are the universal matrices of several minerals, and particularly those of the salts, had not yet covered the whole earth, and consequently had not yet communicated the mineral seeds to the earth. Food of the vegetable family, which has vitiated their virtue, and has even changed in some way their first nature. So the family of animals has been made a participant in this defect, because they feed on plants, as it appears mainly in the vine which abounds in tartar, which is its salt, and that this tartar is a kind of mineral. It appears by his action, which works powerfully on minerals, and which acts with great efficiency on metals, since every action is done by its like. And there must be some relationship between the agent and the patient, but in order not to give rise here to many objections, I only intend to speak in this place of a generic similarity. After having explained these things, it is easy to understand what impure is properly. These are principles of different natures, which are mixed with other principles which are not of their family, nor of their category, as when minerals unite in some way with animals, or with plants. It is no longer very easy to know how the pure gets into all things, by the opposition that we will make of what we have said of the impure. But now it is necessary to show, how one can withdraw and drive out the impure, since it is a principle of death and destruction, as the pure is a principle of life, as we have said above. Chapter 3. How one separates the impure from all things. We have said that the impure is what can interrupt the perfection of actions, which lead the mixture to its natural predestination. It is therefore very necessary to know the means of delivering it from this domestic enemy, which slips imperceptibly into compounds. Now, as the mixtures are under various genera and under different species, and as there are several kinds of impure, men have also invented several arts, to remove and to correct all the differences of these impurities. And as chemistry has for its object in general all natural things, it also strives to show how we can guarantee them all from what is impure in them, but because it would be going beyond the limits of an abridgment to undertake to particularize all the parts of this teaching, we will content ourselves only with speaking of the impurities which are met with in chemical operations. For it is not our intention to treat here of latrochemistry, or medical chemistry, which alone could fill several volumes. Notice only in passing that there are two ways to cast out the impure of all things. The first is universal, and the other is particular. The first is a universal medicine which is drawn, or which can be drawn from several subjects, after having reduced them, as much as possible to art, to their universality, after having removed their specification and their natural fermentation, which had made them such and such a determinate mixture. For as soon as this medicine is reduced to the highest degree of its exaltation, by digestion, by accoction and by a required ripening, it is capable of bringing the impure out of all bodies indiscriminately, because it imperceptibly consumes this impure, as much by means of fixation as by that of volatilization. The second is a particular medicine, which can drive out by its faculty and by its specific virtue, a particular impurity, which is however not of little importance, since these secrets are found only by those who put their hands at work, and who combine continual work with relentless study, who reason about things after having done them, and who only risk them on the sick by an experience supported by the infallible theorems of beautiful philosophy and true medicine. Because it imperceptibly consumes this impure, as much by means of fixation as by that of volatilization. The second is a particular medicine, which can drive out by its faculty and by its specific virtue, a particular impurity, which is however not of little importance, since these secrets are found only by those who put their hands at work, and who combine continual work with relentless study, who reason about things after having done them, and who only risk them on the sick by an experience supported by the infallible theorems of beautiful philosophy and true medicine. Because it imperceptibly consumes this impure, as much by means of fixation as by that of volatilization. The second is a particular medicine, which can drive out by its faculty and by its specific virtue, a particular impurity, which is however not of little importance, since these secrets are found only by those who put their hands at work, and who combine continual work with relentless study, who reason about things after having done them, and who only risk them on the sick by an experience supported by the infallible theorems of beautiful philosophy and true medicine. Who can drive out by his faculty and by his specific virtue, a particular impurity, which is however not of little importance, since these secrets are found only by those who put their hand to the work, and who join a continual work to a relentless study, who reason about things after having done them, and who only risk them on the sick by an experience supported by the infallible theorems of beautiful philosophy and true medicine. Who can drive out by his faculty and by his specific virtue, a particular impurity, which is however not of little importance, since these secrets are found only by those who put their hand to the work, and who join a continual work to a relentless study, who reason about things after having done them, and who only risk them on the sick by an experience supported by the infallible theorems of beautiful philosophy and true medicine. To return therefore to our operations, we have already said that the artist separated from each mixture by means of fire, 5 substances, or 5 different principles, which, although very pure, can nevertheless be said to be impure in various respects, either towards each other, or towards our intention. For if we need only the spirit of something, and that spirit be mixed with some portion of the phlegm of this mixture, we say that this spirit is impure in this respect, and so in the other principles. Now, as regards the particular means of separating these sorts of impurities, we will deal with it in the following book, and particularly in the first chapter of the last book, to which we refer for this purpose. Chapter 4. Pure substances derived from mixtures. One can also draw essences from mixtures, besides the 5 substances, or the 5 principles that we have said that one draws from them by means of fire, and that by the diversity of chemical operations, which change the same principles of these mixtures, and which lead them to their purity. These essences will not only be of a body completely dissimilar to that of the compound from which they are drawn, but they will still have qualities and virtues much more effective than those with which their body was adorned during its integrity. They will even have much more of it than any of the principles of this same compound, after its dissolution and after the artificial separation which will have been made of it. But although these marvelous essences have various names among the authors, who call them mysteries, magisteriums, elixirs, tinctures, panaceas, extracts and specific, they are nevertheless included under the general word pure. It is said in this way, because after having drawn these essences from the mixtures, one ordinarily rejects the rest as impure. Paracelsus says in his first book of the Archidoxes, that the 6 following preparations, namely, the essences, the mysteries, the elixirs, the specifics, the tinctures and the extracts, are contained in the mystery of nature, which he calls the pure, and this very skillfully according to the Greek word pure, which means fire, as if he wanted to insinuate that these essences are brought together, and as if rendered similar to their first principle, which is of the nature of fire, since light, which is only fire, is the first principle of all beings. He also calls in the same place the body, the impure, which retains this mystery in prison. This is why he says, that it is necessary to strip this mystery of all corporeality, if one wants to enjoy it, which will be shown in part 2 of this treatise. But it is necessary to remark here, that when Paracelsus says that it is necessary to strip this mystery of its body, he only claims that it is necessary to remove its gross body, in which it is imprisoned, to give it a more subtle one, from which he can easily disengage and spiritualize, so that it is able to pass into our last digestions, and to correct all the faults that the impure may have caused there. This mystery is sometimes drawn from a single mixture, like the magisterium. It is sometimes derived from several compounds, like the elixir, as we will show below. But it will not be out of place to make a short treatise on compounds, both perfect and imperfect, and their variety, because we have often spoken of them in this treatise, and will speak of them again, since these mixtures are the subject and matter of chemical operations, so that it can be useful, as for the proper part of physics, to which we can have recourse to know well the category of each body. We shall deal in the last chapter of this book with the generation and natural corruption of bodies and their variety. Chapter 5. Of the generation and the natural corruption of the mixed, and of their diversity. Section 1. Of the order that we will maintain in this chapter. To properly understand the nature of the mixtures and of the mixture, and to understand how they are engendered pure or impure, it is necessary to know beforehand what alteration is, after which it is necessary to know what it is that generation and corruption. This is why it is good to say something succinctly about the nature of alteration, generation, corruption and mixture, before listing all the mixtures, both perfect and imperfect, which are the fruits of nature, the object of chemistry, and consequently the subject of its operations. Second section. Of the alteration, generation, and corruption of natural things. If you want to stop at the etymology of this word alteration, you will find that it is nothing other than a movement by which a subject is made or made different from what it was before, or even, it is a movement by which a subject is accidentally changed in its qualities. It is in this that alteration differs from generation, for generation is an essential and substantial change, and alteration is only an accidental movement of qualities. Thus alteration is only a disposition and a way to arrive at generation or corruption. Hence it comes that there are two kinds of alteration. One which is perfective, and the other which is destructive. In the perfective alteration, all the qualities keep a just proportion, and an equal harmony according to the nature of their subjects, either to preserve this nature for them, or to make them take on a more perfect one. But in the destructive or putrefactive alteration, the qualities are disturbed so strongly that they completely distance the subject from its natural constitution, as often happens with fluid bodies, which have a large quantity of phlegm, for example, in wine, when it begins to spoil and stale. Here, then, is the difference between alteration and generation. It is that the alteration does not cause the subject to acquire any new substantial form, but what is substance in this subject, receives some quality in itself, of which it was destitute before. For example, when cold or heat is generated in some plant, or in some animal. But generation is a change of substance, which presupposes not only the production of new qualities, but also that of new substantial forms, as when from bread, blood is generated, the subject or matter of this bread is not only deprived of the quality of bread, but also deprived of the essential and substantial form of bread, to put on the quality and form of blood. Note, however, that a question can be asked here, to which there was no lack of an answer, when one makes a nurse eat some medicinal herb, to communicate the virtue of this herb to her milk, one asks, if it is the same digital quality, which was in the grass which is found in milk. The answer is no, although it is the same specific quality, or rather the same generic quality, for as milk and a plant are of different kinds, the difference in their quality should also be quite generic. But to speak more clearly of these things, let us rather say with Van Helmont, that the virtue of the plant was enclosed in its middle life, which is neither altered nor corrupted by digestions, and that thus it has been carried into the milk, without amusing ourselves any more with the ordinary quibbles of the school, which produce many more doubts than they make us conceive of truths in physics. You will learn from here, how the generation of one thing corrupts another, and on the contrary, how corruption makes generation. This is why we will say nothing about corruption, because whoever understands one of these things well, will not ignore the other. We will only show in a few words how generation and corruption differ from generation. Creation and annihilation or destruction. The difference is, that generation and corruption presuppose a matter, which must be the subject of these various forms, but creation and destruction require no matter, for as one is the production of something drawn from nothingness, the other is also reciprocally the annihilation of something created. Generation and corruption are movements of nature, and of a secondary and finite cause, but creation and destruction can only come from an infinite cause, because there is an infinite distance between being and non-being, between something and nothing. These things thus explained, come to the mixture, which is double, namely, one which is improper or artificial, and the other which is proper or natural. The improper takes itself for a local approach to bodies of various kinds, which are confusedly joined together, thus a heap composed of wheat and barley is said to be improperly mixed. This artificial mixture, in which the parts are really mixed together, but without alteration or change of the whole substance, is also double, namely, that which is made by apposition of the parts, and that which is made by confusion. The affixing is done, when the things, which are mixed together, are divided into such small parts, that one can hardly see them, as when the particles of barley and wheat are mixed together. Confusion occurs when the things that are mixed together are not only divided into imperceptible parts, but are also so confused with one another that they cannot easily be separated, as when the chartiers mix water in wine, or that the apothecaries mix drugs together, which melt together in such a way, that none can be discerned. Natural and proper mixture is a close union of substances, from which something substantial results, which is nevertheless distinct from the other substances which constitute it by means of their alteration. Because by the conjunction of the principles, it generates a mixture, of which the principal form is different from that of its own principles, as one sees it by the resolution of this mixture, according to the maxim of Aristotle, who says that, quod est ultimum in resolution, id sunt primum in composition. This alteration which causes union, to arrive at union and mixture, was depicted, when we spoke of the function of salt and spirit, of the action of phlegm and sulphur, which tame the acidity and acrimony of salt and mercury, and when we said that the earth gives body and solidity to all these various substances. It is by means of this alteration, this union and this conjunction, that the natural compound is formed and made. If it is nevertheless objected that these principles are rather artificial than natural, the answer is found in the first section of the 3rd chapter of the preceding book. Section 3. Of the difference of the mixed in general. After having quite amply discussed simple, pure and homogeneous substances, which we have called principle, after having clarified their various alterations before their union and before their mixture, which complete the perfection of the compound, it remains for us to speak of the mixtures which result from this action. The mixed ones are perfectly or imperfectly composed, according to the strength or the weakness of the union of their principles. The body which is imperfectly composed is that which has only a slight coagulation of some principle, which is not of long duration, and which has no mass or substantial form, which makes it essentially different from its principles. Like snow or ice, which are different from water only by the addition of some foreign qualities. The perfect mix, on the contrary. We call meteors those bodies which are imperfectly composed, whose difference is great, according to the diversity of the principles with which they abound, for there are some which are sulphureous, others which are nitrous, and the third aqueous ones, and so on the others. We must say something about this, before speaking of the mixtures, which are perfectly composed, and in this, we will imitate nature, which never produces a perfect mixture, that it has not passed its principles through. Meteoric nature, as we will say below, because it must not, nor can to pass from one extremity to the other, without passing through any medium. Meteors are called imperfectly mixed bodies, not that they have the nature and form of mixtures, but because by keeping in some way the nature of the principles, they do not, however, differ in any way from the natural state of these principles, and this is why they seem to be of an average condition and nature between pure and simple principles, and between bodies which are perfectly composed of these same principles. They are also said to be imperfect mixed, because of their sudden generation, as well as for their sudden dissolution, for like the coagulation, or the mixing of the principles is imperfect in these bodies, so they cannot be durable, but they suddenly and easily return to the nature of the principle which predominated in them. The distant material cause of these imperfect mixtures, or of these meteors, are the principles, as the closest are the fumes or the spirits, to which these same principles are volatilized and spiritualized. But notice here, that there are two kinds of spirits or smokes, which are quite different from each other, viz., vapors and exhalations. Vapor is a hot and humid spirit or smoke, and which consequently is produced from phlegm, if it is aqueous, oil and sulphur, if inflammable, or mercury, if it is windy and spiritual. The exhalation is a hot and dried smoke, which is therefore engendered from an earthly body and a salt principle. It is also necessary to take care, that the vapor is said to be hot and humid, because the water is converted into vapor, and that it is raised upwards by means of the fire that it has in it, and for this reason it is called a meteor, or a body imperfectly composed of a few principles. Limits of an abridgment, such as we proposed it in the foreword, to speak about it exactly in this chemical treatise. Section 4. On the diversity of perfect mixes. After having shown that nature always tends to the corporification, and to the spiritualization of the mixtures and of the principles, by means of the universal spirit, and by the virtue of the character of the particular matrices, which is done by the operation of the ferment, and by the impression of the idea once received, we must also speak of these mixtures, which are generated, as we have already said several times, by the soul spirit universal, clothed in some meteoric idea, as we see in the resolution of metals and other minerals, which are converted into fumes and exhalations, before slipping away from our sight, to reunite with the universal spirit, from which we gather that they must also have kept and observed these same degrees of production, in their generation. The body which is perfectly composed, is animate or inanimate. The mixed animate, is that which is adorned with a soul or an invigorating form, like the plant, the beast and the man. On the contrary, the mixed inanimate, is that which is deprived of all apparent life, which consists to feeling and sensitive movement. But one asks, if the minerals are animated or not, to which we answer briefly, without bringing the ordinary reasons not to bore, that still one does not perceive in these bodies, which are the fruits of the center of the earth, vital operations so manifest, as those which are noticed in plants and in animals. However, they are not entirely devoid of them, since they multiply by a continual perpetuation, which means that as they have a multiplicative form of their species, they also have life. Some ancients recognized this life, as Pliny testifies, when he says in the 10th chapter, 3rd book of his Natural History, Spumum nitri fieri, cum ros dicit, pragnantibus nitrarius, sed non perientibus. Let us therefore conclude that minerals live as long as they are attached to their root and to their matrix, since they grow there, but when they are separated from them, they are justly called inanimate mixtures, just like the trunk of a tree, which is separated from its root, is legitimately called dead. We shall henceforth call them in this sense, inanimate bodies, as well as many others, though derived from animate bodies. In this way, there are two kinds of inanimate bodies, some are drawn from the earth, and the others are drawn from the same mixtures, either animate or inanimate. Those which are taken from the bowels of the earth are called minerals. There are three kinds, namely, the metals, the stones and the mineral means, which are also called marcasites. Metal is a mixture which expands under the hammer, and which melts in the fire. Marcasites are fusible in the fire, but do not expand under the hammer, and the stones do not expand under the hammer, nor do they sound in the fire. As for the mixtures, which are not drawn from the earth, they are usually drawn from living bodies, by human artifice, such as fruits, seeds, roots, gums, resins, wool, cotton, oil, wine and various other parts extracted, and separated from plants and animals, which are no longer considered organic retort. Whole animals are also used, when they are deprived of their life and their soul. We will deal briefly with all these mixtures, both animate and inanimate, in the following sections. Section 5. Mineral means or marcasites. The mineral means are fossils, which have a middle nature between metals and stones, because they partake in some way of the essence of these two bodies. They agree with the metals by their fusion, they also correspond to the stones by their friability. The mineral means are most of the metallic juices, dissolved or condensed, or else, they are metallic and mineral earths. The main metallic juices are, first, salt, which is a very friable body, which dissolves when wet and which coagulates when dry, which makes us judge that the principle which abounds in this mixture, is the salt from which it takes its name. We therefore judge that since it is a mixture, it is not also consequently deprived of the other principles, as we see by the action of fire on this compound. Salts are natural or artificial. Nature engenders the first, which are called fossil salts. Art makes artificial salts. This is why there are several species, such as rock salt, ammoniacal salt, saltpetre, or niter salt, well salt, sea salt, fountain salt, alums and vitriols, which all have specific qualities, which are different from each other, according to the nature of the principles which abound in them, and which are either fixed or volatile, or which are solvents or coagulants, as can be seen by the diversity of the operations, which can be made on each species of these salts. The bitumens follow the salts. They contain under them a great diversity of species, such as are, asphalt, amber or carob, ambergris, camphor, naphtha, oil and sulphur, and notice that we are not speaking here of the principal sulphur of all things, but only of a fatty and fetid mineral juice, which has in itself a subtle part, which is inflammable, and another which is terrestrial and vitriolic, by which it destroys metals, and is easily extinguished if it abounds. The sulphur we use is either live, that is to say, such as it is drawn from the earth, and which has not passed through the examination of fire, by means of which it is prepared, as we see it in the form of cannons or Magdalians. The art draws from these bituminous mixtures several different remedies for medicine, as we will see in the last book of the second part of this chemical treatise. Arsenic is either natural or artificial. The natural contains under it three species, which are stonecrop, so named from its gold color, the sandarac, which is red, and the realgar, which is yellow. The artificial is made by the sublimation of the natural with salt. Antimony is also natural, which is also called mineral, or artificial, which is the one we buy, which has gone through melting and which is reduced to loaves. We will speak particularly of the choice that must be made of it, of its constituent parts, and of the different kinds of this mineral in practice. Cinnabar is a mineral body composed of sulfur and mercury, or quicksilver, which are coagulated together to a stony hardness. The natural comes from the mines, which is more or less mixed with sand. The artificial is made by the sublimation of sulfur and mercury mixed together. The cadmium is natural or artificial. The natural one is a metallic stone, which contains in itself the volatile salt and the impure of some metal. There are an infinity of species, which are different in color, in virtues and in consistency. The artificial is found in the furnaces, where metals are smelted, and it is nothing other than volatile salt, or the flour of metals, which sublimates itself and attaches itself to the walls of the furnace, or which rises like mad flour to the roof of the place, where metal castings. There are also different species, such as the pomphylix, the spode and the turri. The other species of marcasites are the mineral earths, such as boles, lemnos earth, silesia earth, blois earth, chalk, clay and all other kinds of mineral earths. We could also add artificial earth, like the different kinds of lime which are made of various stones, which contain in them a corrosive salt and a hidden fire. But before beginning the section of metals, it is necessary to clear up a difficulty which presents itself here, that is, since the salts are placed between the metallic juices, how can it be that the ammoniacal salt, which is a salt, and some species of metallic earths, of which we have spoken, are placed among the marcasites, since the marcasites, or the mineral means, do not extend under the hammer, but that they melt nevertheless, because it is certain that the ammoniacal salt does not melt. On the contrary, it sublimates, and even though these earths do not also melt, but they calcine, or sublimate into metallic flours. To which we must reply, that it is true that if we put the ammoniacal salt alone in a crucible, it will not melt, but it will sublimate, that it is nevertheless true that if one mixed this same salt with other salts, it would melt with them, as one also sees that if one mixes the metallic earths alone with fire, they will calcine rather than melt, but if they are alloyed with some fusible body, they will melt together, as when calaminar stone is mixed with an equal weight of rosette copper, it melts with this metal, and changes it into yellow copper which is called brass, and increases it by 50%. It should therefore be noted, that when one divides fossils into metals, stones, and marcasites, one must understand nothing else by marcasites, or by mineral means, than bodies which have some medium or some relation with the nature of the stones, or with that of metals, either because of fusibility, or because of extensibility, or because of hardness, or softness. Thus this beautiful mixture, which seems to be the masterpiece of the art which is glass, must be related according to this sense to marcasite, since it melts easily, and yet it cannot be extended under the hammer, if you do not accept the one which was rendered malleable in Rome, the secret of which perished with its author and its inventor. Then bodies which have some medium or some relation with the nature of stones, or with that of metals, either because of fusibility, or because of extensibility, or because of hardness, or softness. Thus this beautiful mixture, which seems to be the masterpiece of the art which is glass, must be related according to this sense to marcasite, since it melts easily, and yet it cannot be extended under the hammer, if you do not accept the one which was rendered malleable in Rome, the secret of which perished with its author and its inventor. Then bodies which have some medium or some relation with the nature of stones, or with that of metals, either because of fusibility, or because of extensibility, or because of hardness, or softness. Thus this beautiful mixture, which seems to be the masterpiece of the art which is glass, must be related according to this sense to marcasite, since it melts easily, and yet it cannot be extended under the hammer, if you do not accept the one which was rendered malleable in Rome, the secret of which perished with its author and its inventor. Must relate in this sense to marcasite, since it melts easily, and yet it cannot be extended under the hammer, if you do not accept the one which was rendered malleable in Rome, the secret of which perished with its author and its inventor. Must relate in this sense to marcasite, since it melts easily, and yet it cannot be extended under the hammer, if you do not accept the one which was rendered malleable in Rome, the secret of which perished with its author and its inventor. Sixth section. Metals. Metals are hard bodies generated in the particular matrices of the bowels of the earth, which can be stretched under the hammer, and which can be melted in the fire. The number of metals is usually septenary, which is related to the number of the 7 planets, whose names are applied to them by chemists. Metals are divided into perfect and imperfect. The perfect are those which nature has pushed to a final end. The marks of this perfection are the perfect fixation, a very exact mixing and union of the constituent parts of these bodies, which is followed by weight, sound and color, which are capable of a long fusion and of a very strong ignition, without altering their qualities and without losing their substance. There are 2 of this nature, which are the sun and the moon, or gold and silver. The imperfect metals are of 2 kinds, namely, the hard and the soft. The hard ones are those which put themselves in ignition rather than in fusion, like Mars and Venus, or iron and copper. The soft ones are those which melt rather than ignite, like Jupiter and Saturn, or tin and lead. We put for the 7th metal, mercury, or quicksilver, which is a liquid metal which we call for this reason, fluid, as we call the others, solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them. Several even want that it is the first matter. The hard and the soft. The hard ones are those which put themselves in ignition rather than in fusion, like Mars and Venus, or iron and copper. The soft ones are those which melt rather than ignite, like Jupiter and Saturn, or tin and lead. We put for the 7th metal, mercury, or quicksilver, which is a liquid metal which we call for this reason, fluid, as we call the others, solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them. Several even want that it is the first matter. The hard and the soft. The hard ones are those which put themselves in ignition rather than in fusion, like Mars and Venus, or iron and copper. The soft ones are those which melt rather than ignite, like Jupiter and Saturn, or tin and lead. We put for the 7th metal, mercury, or quicksilver, which is a liquid metal which we call for this reason, fluid, as we call the others, solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them. Several even want that it is the first matter. Or iron and copper. The soft ones are those which melt rather than ignite, like Jupiter and Saturn, or tin and lead. We put for the 7th metal, mercury, or quicksilver, which is a liquid metal which we call for this reason, fluid, as we call the others, solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them, several even want that it is the first matter. Or iron and copper, the soft ones are those which melt rather than ignite, like Jupiter and Saturn, or tin and lead. We put for the seventh metal, mercury, or quicksilver, which is a liquid metal which we call for this reason, fluid, as we call the others, solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them, several even want that it is the first matter. Solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them, several even want that it is the first matter. Solid. However, some strike it out of the number of metals because of this fluidity, and place it among things which have an affinity with metals, as being a kind of meteor which holds the middle between them, several even want that it is the first matter. Metals and minerals are divided into two sexes, and various menses are used for their dissolution. Thus it is only aqua regia which can dissolve gold, lead and antimony, which are claimed to be male, and simple strong waters are capable of dissolving all the others which are believed to be the females. Before finishing this section, it is necessary to clarify in a few words some questions which are made on the metallic nature. We first ask if, when several metals are fused together, there results after this mixture some metallic species, which is different from the metals of which it is composed. We must answer in the negative, because it is not a true mixture, and even less a close union, but it is rather a confusion, since they can be separated from each other. Or still doubt on the metals differing between them specifically, or if they don't differ only in terms of plus and minus perfection. Scaliger answers this question, that nature has not rather produced other metals to make gold, than other animals to make men. Moreover, one can say that God created the diversity of metals, as much for the perfection and embellishment of the universe, as for the different uses to which they are employed by men. It must nevertheless be admitted that minerals and imperfect metals always derive from one or the other of the two perfect metals, and most often from both together, as is proved by the extraction made of them by those who have the secret of this separation, either after a previous digestion, or by examining them by the true separator, which is the external fire, which excites the power of the inner fire of things, and which is the only instrument of the wise to bring out the truth of what I have just said. Which leads to the conclusion that these imperfect metals and minerals continually tend to the perfection of their natural destination, while they are still in the womb of their mother, what they can no longer do, when they are torn from their wombs. This question is usually followed by that which asks if art is capable of changing an imperfect metal, to push it by this metamorphosis to the perfection of one of the two principal luminaries. Here we must answer in the affirmative, because it is true that nature and art can make beautiful transmutations by applying the agent to the patient, but the difficulty is almost insurmountable, especially since it is necessary to find precisely the point and the weight of nature, and it is this work that has tormented for several centuries the minds of so many stubborn curious, that made them wear out their own bodies and empty their purses. The last question that arises is whether gold can be made drinkable. This must not be doubted, because experience shows that it can be put into liquor, but the main thing is to know if this liquor can nourish, as many claim. This is what I absolutely deny, because there is no analogy, and no relation between gold and our body, which nevertheless must necessarily be found between the food and the fed body. Now, there is no proportion between the metallic nature and the animal nature. It must not however be doubted that this liquor is a very sovereign medicine, when it is made with a solvent which is friendly to our nature, and which is capable of volatilizing the gold in a way, that it is not possible for art to recorporify it into metal, because when it is reduced to this point, it is then that it passes into the last digestions, where it corrects all the faults that are found there, and thus it alters and changes our body for the better, provided that we know well the use and the dose, otherwise it would be rather a devouring enemy, than a pleasant and familiar guest. Section 7. Rocks. Stones are hard bodies, which neither expand under the hammer nor melt in the fire. They are engendered in their particular wombs, from a juice imbued with the idea and the lapidific ferment. They take their various colors from various mines, through which passes their lapidific juice and their smoke, or their coagulative spirit. The stones are opaque or transparent, the transparent are colored or colorless. Thus we can say with appearance, that the coagulative spirit of the emerald passes through a mine of vitriol or copper, that of the opal by a mine of sulphur, and that of the ruby and the carbuncle by a mine of gold. Garnets and some other stones of this nature get their color from iron, and this is proven by the magnet stone which attracts them to itself, and thus other stones, but the coagulative spirit of the diamond. And the rock crystal is only a pure and simple petrifying ferment, which is deprived of all tingent sulphurity, which consequently only causes them this beautiful transparency that they have. We notice that the opaque or pellucid stones are not generated only in the entrails of the earth or in the waters, but that they are also generated in the entrails and in the viscera of all kinds of animals, such as prove the most curious physicists. This be said briefly touching the nature of minerals, for as regards the doctrine of their particular history, it must be sought among the naturalists who wrote expressly and exactly about it, like Georgius Agricola and Lazarus Oelker, for we only intend to make an abbreviation of the categories, to which we can relate all the natural mixtures which will arise from them. Section 8. Others mixed, both animate and inanimate. We said that there were two kinds of inanimate mixed, namely, those who are drawn from the bosom of the earth, and those who are not drawn from it. This is why it only remains to speak to you of the last, since we have discussed the first sufficiently, according to the intention of this compendium. Those which are of this last order are the juices and liquors which are drawn from plants by expression, as well as animals mediately or immediately, as wine, oil, vinegar, gums, resins, fruits, fats, milk, corpses and its various parts, and many other things which serve as a remedy for the preservation and restoration of human health. The animated mixtures are plants or animals. Plants or plants are perfect or imperfect. The perfect plants are those which have roots and a surface, and the imperfect are those which lack either root or surface. Truffles are of this species, for all their substance is root, and mushrooms, which we do not see at all, or its little root. Perfect plants are divided into grass, shrub and tree, and each of these genera is further subdivided into an infinity of different species, of which botanists give the names and properties. The parts of the perfect plants are principal or less principal. The main ones are those which serve as the vegetative soul to carry out its functions. They are similar or dissimilar. Similar ones are liquid or solid. The liquids are the juices and the tears, that if they are aqueous, they coagulate into gums, and if they are sulfurized, they coagulate into resins. And this is the reason why gums dissolve in liquors of an aqueous nature, and why resins can only be dissolved by oils or by liquors, which are analogous to them. The solid parts are the flesh and fibers of the plant. The dissimilar parts, that is to say, those which contain in themselves a diversity of substances, are either perpetual or annual. The perpetuals, and those which last a long time, are the root, the trunk, the bark, the marrow, and the branches. Annuals are those that are reborn every year, such as buds, flowers, leaves, fruits. Just as plants have a great diversity of parts, and are divided into several species, also the animals which have similar and dissimilar parts, are divided into a large number of species, because they are reasonable or unreasonable. The unreasonable or the beasts, are perfect or imperfect. The perfect ones are those which have no caesura, and which engender blood for the nourishment of their parts. The imperfect, which are the insects, are those which do not engender blood, and which are divided by caesuras. All beasts, both perfect and imperfect, are either slender, or reptiles, or nereidals, or volatile. If you wish to become learned in the history of these animals, you must read Aldrovandus. Chapter 6. How chemistry works on all these mixtures to draw out the pure, and to reject the impure. You see by the enumeration of these mixtures, how wide the empire of chemistry is, since its work is occupied with such different compounds, for it can take whatever it pleases from all these bodies, or divide it into its principles, by separating the substances of which they are composed, or it uses it to draw the mystery of nature which contains the arcane, the magisterium, the quintessence, the extract and the specific in a much more eminent degree than the body from which it is drawn. Because this body is changed and exalted by the chemical preparation, which separates the impure in order to complete this mystery, as will be seen in the Book of Operations, for one must not content oneself with the study and reading of the works of Paracelsus, and mainly from his books of the orthodoxes, whom I have already recommended to you, but one must also put one's hand to work, to enter into the intelligence of one's enigmas, without being put off by the time one must employ, for the trouble one takes, nor for the expense one job, as are usually those who believe and who imagine that they can become skillful by reading a few authors, who base themselves only on the authority of their predecessors, and who leave behind experience and the search for the secrets of nature, although it is the main pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. To enter into the intelligence of its riddles, without being discouraged by the time that one must employ there, for the trouble that one takes there, nor for the expense that one employs in it, as are usually those who believe and who imagine that they can become skillful by reading a few authors, who base themselves only on the authority of their predecessors, and who leave behind experience and the search for the secrets of nature, although it is the main pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. To enter into the intelligence of its riddles, without being discouraged by the time that one must employ there, for the trouble that one takes there, nor for the expense that one employs in it, as are usually those who believe and who imagine that they can become skillful by reading a few authors, who base themselves only on the authority of their predecessors, and who leave behind experience and the search for the secrets of nature, although it is the main pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. Nor for the expenses which are employed in it, as are usually those who believe and who imagine that they can become skillful by reading a few authors, who base themselves only on the authority of their predecessors, and who leave behind experience and the search for the secrets of nature, although it is the main pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. Nor for the expenses which are employed in it, as are usually those who believe and who imagine that they can become skillful by reading a few authors, who base themselves only on the authority of their predecessors, and who leave behind experience and the search for the secrets of nature, although it is the main pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. Although it is the principal pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. Although it is the principal pillar of all good natural philosophy, and consequently that of good medicine. To achieve our goal, we will finish our theory to enter the practice, so that one makes the other better heard. Second part. Book first. Necessary terms, to hear and to do the chemical operations. Preface. We have shown in the first part of this treaty, the foundations on which the whole theory of chemistry is based, but because we said in our foreword, that chemistry is a sensitive philosophy, which does not receive and which does not admit that what the senses demonstrate to him and appear to him, it is time to come to practice and operations, to examine whether what we have said is based on the senses. No one should find it strange that science puts its hand to work, since the operation is only for the contemplation, and the contemplation is only for the operation, which means that these two things must be inseparable. And if it is true that all doctrines and all sciences must begin with the senses, according to this maxim which says, nihil esse in intellectu, quin prius non surat in sensu, I find it very fitting that one should have well-informed and well-educated senses of several experiences before one can occupy oneself theoretically and contemplatively on all natural things, lest one fall into the same faults of these superficial philosophers, who are content to philosophize on the principles of some science, the falsity of which experience discovers. For example, is it not a manifest error to persuade oneself that the flame or the smoke, which comes out of some mixture by a violent resolution, is a fire or an elementary air, and something very simple, since if kept in an alembic, or in some other receptacle, experience will show to the senses that this flame or smoke is not pure insanity, and that they are not also imperfect mixtures, but that it is sometimes the very body of a very perfect mixture, as it appears clearly by the sublimation of the sulphur, and by that of the ammoniacal salt, as well as by the fumes of mercury, which is quicksilver, which is nothing other than the same mercury, which takes all sorts of forms and colors, like the Protheus of the ancient poets, but who nevertheless regains his first being by revivification. Like the Protheus of the ancient poets, but who nevertheless regains his first being by revivification. Like the Protheus of the ancient poets, but who nevertheless regains his first being by revivification. What we have just said shows that we must not judge things rashly, like saying that all smoke is air, for whatever resemblance it may have to air. For although all vapor and all exhalation are similar to sight, yet they are of a different nature, as is seen by those who examine them thoroughly, after having lodged them in their vessels, and this is what we will be seeing by the operations, which we will deal with later. But because we encounter in the practice of these operations several terms, which are essential to the chemical art, and which are rather difficult to understand, it is necessary to explain them before beginning to speak of the practice. Thus we will deal in this book, first, with the various kinds of solutions and coagulations, because one of the principal ends of chemistry is to spiritualize and corporify, in order to separate by this means the pure from the impure. After which we will teach the various degrees of fire, by means of which one achieves with the help of several furnaces, and of many vessels will dine at this true exaltation, which draws from the mystery of the nature of each mixture, the arcane, the elixir, the tincture, or some sublime essence, which is graduated to such a point, that a single drop, or a single grain of these marvelous remedies, have more effect without comparison, than several pounds of the coarse and corporeal mixture, from which these medicines will have been drawn. Chapter 1. Various species of solutions and coagulations. Although chemistry has for its object all natural bodies, however, she works particularly on the mixed body, the exaltation of which she teaches, by means of solution and coagulation, which contain under them various kinds of operations, which all lead either to spiritualization or to corporification. Minerals, plants, or animals, so that the exaltation of some mixture is nothing other than the purest part of this same mixture, reduced to a supreme perfection, by means of various solutions and coagulations which will have been withdrawn several times. To achieve the reduction something to the point of its exaltation, one must first separate the pure from the impure, which is done materially or formally. Materially, by cribration, ablution, sweetening, debridement. After having made the separation of the pure and the impure, it is necessary to reject the impure to arrive at a perfect exaltation, and to put the pure, first in solution, and then in coagulation, which is done either by reducing it into very small parts, or into liquor or into some solid body, by means of the following operations, viz., lime, ration, pulverization, alcoholization, incision, granulation, lamination, putrefaction, fermentation, maceration, fumigation which is dried or wet, cohobation, precipitation, amalgamation, distillation, rectification, sublimation, calcination, which is actual or potential, vitrification, projection, lapidification, quenching, fusion, liquefaction, cementation, stratification, reverberation, freezing, crystallization, fixation, volatilization, spiritualization, corporification, mortification and revivification. And it is of all these different terms that we must give a clear understanding in this chapter. The cribration is when we pass the beaten material through the mortar through the sieve or through the sieve, one is the perfect bruise, and the other the coarse one. The ablution or the lotion is done when one washes its matter in water, to clean it of its coarsest impurities. And when matter has descended to the bottom of the water by its gravity, and the water is poured out by inclination, this is called a fusion. Sweetening is the operation by which the spirituous, saline and corrosive parts are separated from the chemical preparations, which are separated by actual or potential calcination. We purge by Dieter's ion, the matter which cannot stand water, without altering its qualities, or without losing its substance, so that if the matter is put in some suitable liquor, and passed roughly afterwards, either through a cloth, or through some other corridor of cloth or cheesecloth, this is called collation or percolation. But if this operation is done through something more compact and tighter, it will be called filtration, which is done by the sheet, by the paper, or by the tongue. That which is made by paper is the most exact and clearest. Despumation is nothing other than the separation which is made of the scum, or of the other refuse which floats above the materials, with some instrument suitable for this purpose. Limation is the solution of the corporeal continuity of some compound by a file of steel. It has its use in the three families of compounds, for one files the bones of animals, the wood of vegetables, as well as the body of the hardest and most solid metals. The ration has much affinity with the limitation, but it is done with some sharper instrument, as with a knife, or something of the like nature. It can also be related in some way to the incision. The pulverization or contusion is nothing other than the reduction of some mixture into powder, by means of trituration in a mortar, on marble, or on porphyry. That if we reduce matter to a very subtle powder, which is impalpable and imperceptible, this is called alcoholization, which is also sometimes said of liquid things, as we call the alcohol of wine, or of other volatile and inflammable spirits, when these spirits are so stripped of their phlegm, that they burn and the matter, which they have soaked, like linen, paper or cotton. The mineral and metallic materials are turned into shot by granulation, and by filing it, beat it and extend it in small loose blades, like gold, silver and copper in sheets. Putrefaction takes place, when the mixture tends to its corruption, by a humid heat without any mixture, only if this is done by the mixture and the addition of some leaven, which is the ferment, like tartar, common salt, brewer's yeast, sourdough, or ordinary ferment and wine lees. This takes the name of fermentation. Maceration is when you put some matter in infusion in a menstruation, which is only some humor, or some liquor suitable and appropriate for you, to extract the virtue of the compound on which you act. This operation requires time. Proper and necessary for the extraction, according to the more or less fixity of the body, on which one works. Fumigation is a corrosion of the external parts of some body, which is done by some vapor, or by some acrid and corroding exhalation. If it is by a vapor, as by that of vinegar, it is a humid fumigation, and if it is by an exhalation, as by the smoke of lead or quicksilver, it is a dry fumigation, which calcines the metals reduced to blades, and which renders them so friable, that one can afterwards easily grind to powder. Cohobation is done, when it is necessary to often reject the menses, which has been drawn from one or more mixed, on the own feces or the rest of these mixed, either to draw from it the centric virtues, which are enclosed in these compounds, either to make these same feces resupply themselves, and to take up again what they had allowed to volatilize by means of the heat in the distillation. And it is in this single operation that the cohobation takes place. Precipitation makes the body leave the dissolving menstruation, which this menstruation had dissolved, which is done by analogy, which is between the salts and the spirits, for what is dissolved by spirits is precipitated by salts, and on the contrary. This operation requires a particular consideration of the one who wishes to work, because it gives a lot of lights, to understand well the generation and the corruption of the natural things. Amalgamation is a particular calcination of metals, which some authors call philosophical calcination. It is done by means of the union of mercury or quicksilver in the smallest particles of the metals, what separates them in such a way that it makes them smooth and easy to handle, so that by evaporating the mercury at the required heat, the metals are reduced to a very subtle lime, which cannot be done by any other means. Distillation takes place when matter, which is enclosed in a vessel, pushes, chases and sends vapors into another vessel which is united to it, by the means and by the activity of fire. There are three species. The first is that which takes place when the vapors of the things distilled rise upwards. The second, when these same vapors go by the side, and the third, when they tend downwards. Everything is done according to the materials suitable for distillation, and according to the vessels suitable for this purpose. Rectification is nothing other than the reiteration of distillation, in order to make the distilled vapors more subtle, or to deprive some spirit of its phlegm, or of its most earthly and grossest parts, depending on whether they are fixed spirits or acids, or that they are flammable volatile spirits. Sublimation is an operation by which fire causes a whole body, or some of its parts which condense at the top of the vessel, to pass in dry exhalations into loose and subtle flowers, or into a denser, more compact body. And tighter. This way of operating is opposed to precipitation. Calcination is a violent action, which reduces the mixture to lime and ashes. It is double, namely, actual and potential calcination. That which is actual, is done by means of flaming wood, or by that of burning coals, which are material fire, and potential calcination, is that which is done by means of the secret and potential fire of strong waters, simple or compound, and by vapors, or by corrosive fumes, as one notices in precipitation and in fumigation. Vitrification is the change of a metal, minerals, plants, or stones into glass, which is done by means of projection after the fusion, or by the addition of a few fixed and lixivial alkali salts, which penetrate and purify these various substances, and vitrify them by giving them fusibility and transparency. There are, however, many that are opaque, commonly called enamels. Lapidification is done when the metals are changed into stones and pastes, which hold in some way the middle between the metallic and transparent glasses, and the enamels, because they take on a beautiful polish. Extinction is the suffocation and cooling of a burning matter in some liquor, either to draw the virtue of this matter and communicate it to the liquor, or to communicate some new quality to what is quenched, as one extinguishes the tooty and the calamine stone in fennel water or in vinegar, to impart to them more virtue for the eyes, as one also quenches all the instruments which are forged from iron and steel, to give them polish, hardness and consequently a cutting edge. Fusion is properly said of metals and minerals. It is done by a great and violent ignition. And the liquefaction is only said of animal fats, wax and the unctuous, fatty and resinous parts of vegetables, which is done by temperate heat. One removes by cementation the impurities of metals. It is also used for their examination, to know if they are true or false, as one also shrinks their volume, by the tightening of their parts, which is done by means of the stratification, by making a bed of cement, then another of metal blades, and continuing thus, stratum super stratum, or bed upon bed, until the vessel is full. But note that you must always begin with the cement and end with the same, after which, it is necessary to fight. The pot or the crucible vary exactly, to give after that the fire of will by degrees until the fusion. Reverberation is an ignition by which bodies are calcined in a reverberatory furnace with a flaming fire, or that it is done to separate the corrosive spirits from it, or that it is done simply, to subtilize and to open this same body, by means of this operation. Fulmination or fulguration, is an operation by which all metals, except gold and silver, are meteorized, reduced and expelled into vapors, exhalations and fumes, by means of lead on the dish or on the ashes, with a very violent fire, animated by some good and ample bellows. Or make the detonation, to separate and to drive out all the sulphurous and mercurial parts, which are impure in some mixture, so that only the terrestrial part remains, which is accompanied by the internal and fixed sulphur, in which mainly resides the virtue of the minerals. This operation is carried out by means of saltpeter or niter, as is seen in the preparation of diaphoretic antimony, which is done by detonation and by fusion. Extraction is when one draws the essence or the tincture from a mixture, by means of a menstruation or a suitable liquor, which the artist evaporates, if it is vile and useless, but which it withdraws by distillation, if it is precious, and capable of still being used for the same operations. What remains at the bottom of the vessel is called extract. The expression is done to separate the more subtle from the coarser, according to the intention, which one has to keep one or the other. For this we use the press and the plates. Digestion is one of the principal operations, and one of the most necessary of chemistry, because the mixtures are rendered tractable by it, and capable of furnishing what is desired of them. It is practiced by means of a suitable menstruation, and of a long heat. It is usually done in some vessel of encounter, which are two vessels which mouth one into the other, so that nothing is lost of the volatile spirits of the thing that is digested. One ordinarily uses in this operation the heat of the aqueous bath, the vaporous bath, the air, the heat of horse manure, or that ashes, or sand. Digestion has a lot of affinity with maceration. They nevertheless differ from each other, in that it is done by digesting a kind of coction, which is not done in maceration. We withdraw the menses, which serve to dissolve, or to extract into vapor, by means of evaporation, and by this action, desiccation occurs, but by exhalation dry spirits are removed from matter by fire, and are reduced to exhalations. The circulation is an operation, by which the matters contained at the bottom of a pelican or a vessel of encounter, are pushed upwards by the action of heat, then they fall back on their own bodies, or to volatilize them by means of the spirits, or to fix the mind by means of the body, which is very worthy of the contemplation of a man who wishes to be a true naturalist. Freezing is the reduction of the solid parts of animals into jelly, by elixation with some menses, as are the jellies of the horns, of the bones, of the muscles, of the tendons, and of the cartilages, but note that this freezing is only done because of the volatile salt, which abounds in animals, like crystallization, is also properly said of salts, when they are purified by various solutions, filtrations and crystallizations, after the liquor which contains them has been evaporated to film. Volatile things are made fixed by fixation, as, on the contrary, fixed things are made volatile by volatilization. We call fixed what is constant and permanent in the fire, as one calls volatile, that which flees and exhales at the slightest heat. But notice here, that as there is a great diversity of degrees of heat, so there are many kinds of fixed things, and many volatile. Spiritualization changes the whole body into spirit, so that it is no longer palpable or perceptible to us, and by corporification, the spirit resumes its body, and makes itself manifest again to our senses, but this body is an exalted body, which is very different in virtue from that from which it was taken, since this body, thus glorified, contains in itself the mystery of its mixture. By mortification the mixed are as it were destroyed, and lose all the qualities and virtues of their first nature, to acquire others, which are much more sublime and much more effective, by means of revivification. It is this operation which made Paracelsus say that the force of death is effective, since there is no resurrection without it, and as the Apostle St. Paul says, the grain must die in the ground, before reviving, and multiplying in the year that comes from it. Empyreum and empyreumatic, a term taken from the Greek, is an unpleasant odor that the violence of the fire communicates to the mixtures that are distilled. Chapter 2. Of varying degrees of heat and fire. The most powerful agent that we have under heaven, to make the anatomy of all the mixtures, is fire, which needs for its maintenance, first of combustible, oily and sulphurous matter, either mineral, like coal, be vegetal, like wood and coal, and vegetable oils, or finally animal, such as animal fats, axons and oils. In the second place, the fire needs a continual air, which drives out by its action the excrements and the fuliginosities of the matters which are burned, and which animates the fire, to make it more or less act on its subject, and it is this necessity that has led some to say quite incorrectly that air is the real food and the real food of fire. If we want to speak very exactly, one cannot say that the fire receives from itself, nor in itself more or less, or as the philosophers say, that it can receive intention or remission, however the matter on which it acts, can receive several degrees of heat, according to the approach or the remoteness of the fire, or the interposition of things which can receive the impression of heat. Whence it necessarily follows, that the mode and conduct of heat, consists of a just and suitable quantity of fire, which is administered by the artist, according to the conditions of the material on which he is working, and according to the means he uses, to which he must give a proportionate distance. Can receive several degrees of heat, according to the approach or the distance from the fire, or the interposition of things which can receive the impression of heat. Whence it necessarily follows, that the mode and conduct of heat, consists of a just and suitable quantity of fire, which is administered by the artist, according to the conditions of the material on which he is working, and according to the means he uses, to which he must give a proportionate distance. Can receive several degrees of heat, according to the approach or the distance from the fire, or the interposition of things which can receive the impression of heat. Whence it necessarily follows, that the mode and conduct of heat, consists of a just and suitable quantity of fire, which is administered by the artist, according to the conditions of the material on which he is working, and according to the means he uses, to which he must give a proportionate distance. To increase the fire, it is necessary either to put a greater quantity of coal in the furnace, or if there is enough of it, and that it does not act according to the will of the one who works, it is necessary to give entry to a larger air, or by the door of the furnace by which one puts the fire, or what will be better, by giving it by the door of the ashtray, and even by opening the registers, which are at the top or at the sides of the furnaces, to give way to the exhalations and to the Sooty vapors, which ordinarily suffocate the fire, or again, by blowing with bellows, which are ample, and which are capable of a lot of wind. What I have just said must make known that one can weaken the fire by the contrary, like closing the doors and registers, to prevent the entry of air and the exit of soot, or else, one must reduce the combustible material, or cover the fire with cold ashes, or with an iron plate, or with a brick, to prevent the disorder and the accidents which occur in the operations. As for the distance from the vessel which contains the matter, this can only be judged according to the means interposed and the nature of the matter itself. We can nevertheless accept as a general rule that there must be a distance of about 8 inches between the grid or the stove which contains the fire, and the bottom or the bottom of the vessel which must receive the heat, for fire acts on matter, mediately or immediately. Immediately, when fire acts without opposition on the macerate, or on the vessel which contains it, be it a crucible, a retort or something else. And this is what is commonly called the open fire, the fire calcination and fire suppression. Immediately, when there is something which is placed between fire and matter, which prevents its destructive action, which gives the artist the means to govern it, like a skillful squire, who knows how to govern and tame a horse, by means of the reins of the bridle he holds in his hand. We will understand all the differences in the degrees of heat under 9 main classes, which the artist will be able to diversify again in an infinity of ways, according to his intention, and according to the quality of the mixture on which he operates. These differences are as follows. We will take the first degree of heat, by the extreme and by the strongest, which is the fire of flame, which calcines and reverberates all things, and it is properly that which is capable of passing into vapor and exhalations the bodies which are the most solid and the most fixed. The second is that of carbon, which serves properly and principally for cementation, for coloring and for purgation, as well as for the shrinking of metals, as well as for that of the minerals, which are most of a metallic nature. It is sometimes called will fire, and sometimes suppression fire, according as the fire is appropriated above, below, or beside. The third degree of the great fire is that of the blade of iron reddened to the highest point, which is a heat, which serves to experiment and to test the metallic tinctures, as well as the degree of fixation of the mineral remedies. The fourth takes for its subject iron filings enclosed in a capsule, or in a cauldron of the same material, and that, because this body being once heated, preserves its heat much longer than the others, and that it communicates it with a greater activity to the vessel, which contains the matter which must be distilled or digested, or which must be cooked. The fifth is that of sand, to serve as an interposed means. It holds less heat than that of iron filings, because it heats up more slowly, it cools rather, and it is easier to hold it in check by means of appropriate registers. The sixth is the heat of the ashes, which begins to be a temperate heat with respect to the other degrees of fire, of which we have spoken above. This fire ordinarily serves for the extractions of the mixtures, which are of medium substance, either animal or vegetable, and even for their digestions and their evaporations. The bain-marie, or speaking more properly, the marine bath, makes the seventh of our classes, and which is the most considerable of all the others, as being that which makes the most excellent and the most useful part of the work of the chemistry, because the artist can conduct it with so much judgment and with so much proportion, that he can perform with its help a great diversity of operations, which are impossible by any other imaginable way, because it can be boiling, half-boiling, simmering, warm, half-warm, and still hold the middle between all that I have just said. The eighth degree of well-graded fire is the vaporous bath, for one can put the vessel simply in the vapor of the water, which is contained in the marine bath, and for the ninth, you can put sawdust around the vessel, which receives the steam, or oat straw, or finely chopped straw, because they are bodies which easily attract this vapor and its heat, and which preserve it for a long time in great slowness, and in an almost perfect equality. There is still the lamp fire above all that we have just said, which can be graduated, according to the distance and the approach of the lamp, which will have one or more candles. These candles will be composed of 2, 3, 4, or a greater number of wires, depending on whether one wishes to heat the material more or less. This heat is mainly used to cook and fix. Chemists have also invented several other kinds of heat which cost them nothing, like that of the sun, either by exposing their materials to the reflection of the rays of its light, which would have been received by some body, more or less capable of returning them, or by concentrating the rays of this same light, by means of the burning mirror, which is an instrument capable of astonishing the most skillful, who do not know the sphere of its activity, since these less considerable effects are to melt the metals, according to the cut and the large diameter of these admirable instruments. But what is less conceivable is that this heat is a magic fire, which is different from any other fire, since the last is destructive, and this first is conservative and multiplicative, as experience shows in the solar calcination of antimony, which loses by this operation its mercury and its impure sulphur, which are exhaled in smoke, which should decrease in its body, and which acquires a cordial and diaphoretic virtue, with an increase in its weight, which is thus proven. If 10 grains of this mineral are calcined in an ordinary fire, it decreases by 4 and consequently, only 6 remain, which will still be cathartic and emetic, but if you calcine so much with this celestial fire, besides losing its bad qualities by the exhalation which is made of its impurities, which have weight, and which seem to have decreased the 10 grains, it happens that there are 12 of them after the preparation is completed, who are endowed with a quite admirable virtue, and this is what rightly causes the admiration of the rarest minds, for it is increased by just half. But we cease to admire, when we have once known and understood well, that light is this miraculous fire, which is the principle of all natural things, which joins and which unites itself indivisibly to its similar, when he meets him in any subject whatsoever. Artists still use the heat of horse manure, which is a putrefactive heat, which Paracelsus particularly recommends, when it is a question of opening the most solid and most fixed bodies, such as those of metals and minerals. In order to extract more easily the beautiful remedies that he teaches us, we can substitute for the heat of the manure, that of the baths and the mineral fountains, which are naturally hot, as well as that of the sea bath, which is artificial, provided one knows how to govern it with the required proportions. Chapter 3. Of the diversity of vessels. As one does not often put the materials on which the artist works on the open fire and in the open, but that it is necessary that they are enclosed in vessels clean and suitable for the intention of the one who works, that one adjusts and poses artistically and with great judgment on the fire, which acts mediately or immediately, so that what will come out of it is not lost uselessly, but on the contrary, that it is carefully and curiously preserved. It is therefore necessary that we treat in this chapter the diversity of these vessels, and the different uses where they can be usefully employed. Now these vessels must be considered, either according to their material, or according to their form, because they are two essential parts, which are that they are employed in the operations of chemistry, and their difference is as great, as there are different views in the minds of those who apply themselves to this work. And as for several centuries we have been looking for the perfection of the operations of this art, it is also necessary that we draw only in general the greatest part of the necessary instruments, in order to leave complete freedom, for those who will want to work at this beautiful art, after they will have been introduced to it, to reach the most hidden knowledge of the beautiful preparations, which are made by its means. One must always choose the cleanest material for the construction of vessels. It must also be compact and tight, so that the most subtle portions of matter cannot perspire, and that this matter of the vessels is not capable of communicating any quality foreign to simple or compound matter, on which the chemist operates. Glass is the body, which we must use exclusively for any other, because of its tightness and its sharpness, if it were capable of suffering all the actions of fire, but its fusibility and the accidents which break it, notwithstanding all the precautions of the artists, means that it is necessary to have recourse to other materials which are capable of residing in the fire, and which cannot be broken so easily, like potter's clay, which provides chemistry with a good number of vessels for its service, according to the diversity of these earths, and according to their porosity, because if we say that we can coat them with some varnish, mineral or metallic, which will prevent perspiration, the answer will be, that this makes them of the same nature as glass, and that thus it will be subject to the same accidents, for besides their common frangibility, care must also be taken not to expose them too hastily from cold to heat, or from hot to cold, because the compression or the rarefaction would not fail to cause the breakage of each other. That this makes them of the same nature as glass, and that thus it will be subject to the same accidents, for besides their common frangibility, care must also be taken not to expose them too hastily from cold to heat, or from hot to cold, because the compression or the rarefaction would not fail to cause the breakage of each other. That this makes them of the same nature as glass, and that thus it will be subject to the same accidents, for besides their common frangibility, care must also be taken not to expose them too hastily from cold to heat, or from hot to cold, because the compression or the rarefaction would not fail to cause the breakage of each other. We also need metallic vessels, to carry out many operations of the chemical art, which would be very difficult and almost impossible without this help, both because of the action of fire, which destroys and consumes what is subjected to it, and because of the various materials on which the artist ordinarily acts. Because we need glass or glazed earth to contain acids and saline, nitrous, vitriolic and aluminous substances. On the contrary, it is necessary to have metallic vessels, which can resist open fire for a long time, and which contain a lot of matter, when one must draw the spirit from the wine in quantity. One cannot also draw distilled oils from vegetables without these vessels, because these operations need a violent and long fire, to disunite the balsamic and ethereal parts, from those which are saline and terrestrial, which can only be separated with a large quantity of water and by a large boil. But observe never to use any vessel, nor any metallic instrument, when working on mercury, which must henceforth be taken for quicksilver, because this mixture is allied and amalgamated easily with most metals, with some more easily, and with others more difficult. That is said in passing, as regards the matter of the vessels. When working on mercury, which must henceforth be taken for quicksilver, because this mixture easily combines and amalgamates with most metals, with some more easily, and with others more difficult. That is said in passing, as regards the matter of the vessels. When working on mercury, which must henceforth be taken for quicksilver, because this mixture easily combines and amalgamates with most metals, with some more easily, and with others more difficult. That is said in passing, as regards the matter of the vessels. As for the diversity of the shape of the vessels, which must be used for the operations of chemistry, it varies according to the different operations. For we use cucurbits, covered with their capital or their still for distillation, as well as the copper bladder, which must be covered with the Moor's head, made of the same metal or of tin, lest the spirits or the oils which are distilled, draw any vitriolic substance from the copper. It would also be necessary that all copper vessels, which will be used in chemistry, be tin to prevent what we have just said. It is also necessary to use ample and broad basins, on which one will pose a proportioned pewter bell, for the distillation of recent fruits, succulent plants and flowers. These three sorts of vessels will suffice for the distillation, which is made of the vapors which rise above. But it is necessary to have retorts or retorts, and large and ample containers, for the distillation which is made of the vapors, which are forced to come out from the side, which the artists have recognized as necessary, because these vapors cannot be easily raised because of their gravity. It is even sometimes necessary to have open retorts from above, which are either of metal or of earth, as well as containers with 2 and 3 channels, or with 2 and 3 openings, to adjust others to this. First, in order to condense more easily and more suddenly the exhalations and the vapors which come out of the ignified matter, for if this did not happen, it would be necessary either for the vessel which contains the matter to burst, or for the container to jump into the air, if it were alone, because there would not be enough space to contain, receive and temper the impetuosity of the smoke, which the fire sends out. It is necessary to have matras with a long neck, and which are of narrow mouth for digestion. One can also use for this purpose of vessels of encounter, which are 2 vessels, which mouth one into the other, so that nothing can exhale of what is useful. Pelicans are used for circulation, and even twins, which are 2 cucurbits with their capitals, whose beaks enter the belly of the opposite cucurbit. Meetings can also be used for this operation, but they are not so convenient as the 2 preceding vessels. It is necessary to use liddles for sublimation, or some other analogous vessels, like putting earthen pots, which fit into each other, or blind stills, that is to say, without spouts. We also use blue paper, which is sticky and sticky, to make cones of it which receive the exhalations of sublimable materials, as will be seen when one sublimates the flowers of benzoin. For melting or for fusion, as well as for cementation and calcination, it is necessary to have crucibles, which are made of a good earth which resists fire, which is capable of retaining the salts in cast iron, and of prevent the evaporation of their spirits, and even hold the metals in flux, it is also necessary to have lids for the crucibles, which can be removed and put back with the calves, so that the coals, or some other foreign body, do not fall into the material which is in the fire, or that one can fight these covers very exactly, as it is practiced in cementations. You must finally have tranches and bowls, spoons and spatulas of glass, earthenware, sandstone, or some other good earth, which is glazed or unglazed, which will be used for dilutions, exhalations, evaporations, crystallizations, and particularly for air resolutions. Those who want to work on the real fixations will need philosophical eggs, or another instrument which is of my invention, which I cannot call other than by the name of the egg in the egg, or ovum in ovo. It partakes of the nature of the pelican, for the circulation, and of that of this instrument, which is called a hell, because all that one puts into it can never come out. This vessel serves to fix the mercury. It also has the shape of an egg which is enclosed in another, so that it is like the shortcut and the true perfection of these three vessels, which can be used for fixation. However, as the naive description of all these vessels cannot be made in writing, and as the demonstration is much more advantageous than reading, we will have recourse for this purpose to the plate which is at the end of this chapter, where we will see the representation of it, which will serve as a model. Chapter 4. From the diversity of all kinds of stoves. It is not enough for the chemist to have heat and vessels, he must also have furnaces to regulate and to govern his heat and his fire, to apply and adjust the vessels to the degree of fire, which he deems suitable for his matter. The furnaces are instruments, which are intended for the operations which are by means of fire, so that the heat can be retained and as if restrained, to be able to govern it according to the judgment, the skill and the intention of the artist. They are given various names, according to the diversity of the operations to which they are appropriate. Because they are fixed and immobile, or mobile and portable. We will speak here only of stationary furnaces, since these are those which serve most usefully for the operations of chemistry, and we will leave the others to the imagination of those who will be curious to apply themselves to this beautiful art. The material of the stoves is threefold, namely, the bricks, the bed, and the fittings. Their form is taken from their usefulness. All stoves should have 4 parts, which are absolutely necessary to them, of whatever form they may be constructed, which are first, the ashtray with its door, which serves to receive and remove the ashes which fall from the coal. Secondly, there is the grid, which receives and supports the coal. There is in the third place, the stove or the hearth with its door, to throw the coal on the grid, which must have its registers to govern and to regulate the heat of the lit coal, which is contained therein. There is finally the workshop or the laboratory, which must contain the vessels and the materials on which we work. These are the general remarks which must be made on the material and on the construction of the furnaces. We must then say something about their use, and describe their parts. We must begin with the furnace, which is usually called athanor, which is an Arabic word, or rather derived from the Greek, to mean that this furnace retains a perpetual heat. It is given this name par excellence, because this furnace is not only more useful than all the others, for a large number of operations at the same time, but also because it saves coal, it relieves the care and the assiduity of the artist, and the heat it communicates, can be regulated with great ease. The athanor must have 4 parts. The first is the tower that contains the coal. The second is a water bath. The third, an ash furnace. And the fourth, that of sand. The tower must be 4 or 5 feet in height or approximately, 1.5 feet of breadth outside, and 10 inches in diameter of void inside. It must have its ashtray and its door for the communication of the air, and to remove the ashes, and the door above the grid, which is only used to clean it, and to remove the earth and the stones, which are sometimes found with the coals, which would block the grate, which would prevent the air, and which consequently would extinguish the fire. It is also necessary that this tower have 3 openings 1/2 foot high, and 3 inches wide on the 3 other sides, which are made above the grid, so that they communicate the heat to the bain-marie, to the furnace of ashes and to that of the sand, which must be built contiguous to this tower, to which one will also make for each one an ashtray and a grid with its door, to make use of it in particular without the tower. These holes must be closed with iron plates, which will rise and fall, according to the degree of fire that one wishes to give to one or the other of these furnaces. One can also accommodate a square or round cauldron, which will be used to plug the top of the tower, which can be useful for many operations, and mainly for digestions. This cauldron will fit between two irons, one of which will be the edge of the inside of the tower, and the other that of the outside. It is also necessary that the space between these two irons be filled with ashes, which will prevent the expiration of the heat by the top of the tower, and thus which will be used to block the top of the tower, which can be useful for many operations, and mainly for digestions. This cauldron will fit between two irons, one of which will be the edge of the inside of the tower, and the another that of the outside. It is also necessary that the space between these two irons is filled with ashes, which will prevent the expiration of the heat by the top of the tower, and thus which will be used to block the top of the tower, which can be useful for many operations, and mainly for digestions. This cauldron will fit between two irons, one of which will be the edge of the inside of the tower, and the another that of the outside. It is also necessary that the space between these two irons is filled with ashes, which will prevent the expiration of the heat by the top of the tower, and thus the fire will be forced to push its action from the sides, being called there by the registers, which will be made at each of the three furnaces. This is enough to understand the structure and use of the athanor, because as for the form and the figure, it depends on the artist. We still need a distilling furnace, in which we enclose the copper bladder, for the distillation of brandies, and for that of ardent spirits, which are drawn by means of fermentation, as well as for the extraction of distilled oils, which are improperly called essences. And after having covered the bladder with the Moor's head, it is necessary to have a barrel which has a straight channel, or which is made like a snake, which passes through it, which receives the vapors that the fire drives out, and which condense in liquor in this channel, by means of the fresh water which is contained in the barrel. Those who want to operate on minerals and metals must have a proofing and carboizing furnace, which is nothing but a circle of bricks, 1 foot in diameter inside, and high on the 8 or 9 inches, to which a hole is left for the bellows, after having made the first row of bricks, which must be very exactly joined and bound together by a good nut which resists well to fire. This stove can also be used to cup and to calcine. A laboratory cannot be well accomplished, if it is not provided with a furnace of reverberatory, which must be closed or open. We call closed, the one in which we can distill the strong waters and the spirits of the salts, such as niter, vitriol, common salt and other things of a similar nature. That which is called open is that in which one can reverberate and calcine, by means of the flame which must pass over the material from the back to the front, being attracted there by an opening half an inch wide. And the length of the entire furnace, which is left behind the iron plate, which supports the materials that we want to reverberate, and this same flame comes out through another opening of the same size, which will be along the top of the stove in front, immediately below its lid, which must be flat with no other register than this long opening in the front. You finally have to have a wind stove for mineral castings and 4 metals, for vitrifications and 4 regules. The grid must be placed on a square supported on 4 pillars, so that the wind and air have a free entrance, and thus they serve as bellows. There must be an opening of 1 foot in square to the 4 faces of this base. Then a round tower will be built 15 inches high and 8 inches in diameter on the inside, that the door for the entry of the crucibles be 7 or 8 inches wide, and 10 high. It is necessary to cover this tower with a lid which is domed, with a channel above, which is pierced with a hole 3 inches in diameter, on which another hole 3 or 4 inches high will be fitted. Feet, in order to better concentrate the action of the fire around the crucible or the other vessels, which contain the matter which one wishes to melt. The entrance to the crucibles must be blocked with a door of good earth which is of 3 pieces. But since those who devote themselves to the work of chemistry are not always sedentary, and thus they cannot be provided with all kinds of furnaces, it is necessary that I give the manner of building one of them, which will be able to be used successively for all the operations of this art, provided that one has the necessary vessels, and which are of the same measurement of the furnace which I will describe, which does so. You have to build a stove 1.5 foot square, make the bottom of the ashtray with a flat brick, and continue to raise the surrounding wall with 2 bricks, and leave the void in the middle with the door in front. 4 inches high, which are 2 bricks, then cover the door with a brick, and complete the tour of the square of the same equality, lay the grid which is of 7 iron bars the size of the master finger, which are squarely forged. These bars must be placed on their cutting edge or their edges, so that the ashes can flow better, and so that they do not suffocate fire. That there is only the distance of the thickness of the index finger between each of these bars. Then, after having equalized the thickness of your iron with tiles or with tile, which is about the same thickness, and well fought all together, you must begin to build in a hood, and leave only 6 inches uncovered from your grid, making each bed of your bricks a retreat of 3 lines, which you will continue up to 10 inches of height, which is a necessary space, both to contain the coal, and for the play of the fire. It is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. You must begin to build in a hood, and leave only 6 inches uncovered from your grid, making each bed of your bricks a retreat of 3 lines, which you will continue up to 10 inches in height, which is a necessary space, as much to contain the coal, as for the play of the fire. It is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. You must begin to build in a hood, and leave only 6 inches uncovered from your grid, making each bed of your bricks a retreat of 3 lines, which you will continue up to 10 inches in height, which is a necessary space, as much to contain the coal, as for the play of the fire. It is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Making each bed of your bricks a retreat of 3 lines, which you will continue up to 10 inches in height, which is a necessary space, both for containing the coal, and for the play of the fire. It is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Making each bed of your bricks a retreat of 3 lines, which you will continue up to 10 inches in height, which is a necessary space, both for containing the coal, and for the play of the fire. It is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Then for the game of fire, it is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Then for the game of fire, it is also necessary to leave a door of the same size as that of the ashtray. After having completed this, 2 iron bars of the thickness of 1 inch must be laid flat, at the distance of half a foot from each other. Then level the wall with large tiles, or with some other body of the same thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Or with some other body of similar thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. Or with some other body of similar thickness, and build after that all around 3 side bricks, to have more space to put the vessels necessary for the following operations. If you want to work in a bain-marie, you must have a round cauldron, which is proportionate in diameter to the inside of your stove, and which is only 1 foot high, in order to fit it into this stove, and the space which will be in the corners, will be used to make registers for the evocation, or for the remission of heat. It is also necessary to have another cauldron, which has the bottom of good jail or of iron plank, with the outline which is of less thickness, which is appropriate to enter the same furnace, which will be used to distill and to work with ashes, with sand and iron filings. If this cauldron were made of good cuirass iron, and if it were forged all in one piece, it could also serve as a bain-marie. That if you want to work with the retort, you can put a lid of clay pots, reverse on the bars, and put on this lid a handful of sand, which will serve as a lut to prevent the glass from breaking, and that the fire does not act too quickly on the vessel and on the material it contains, after which, all that remains is to cover the top of the stove with an unglazed earthenware dish, which is pierced in the middle, so that this hole serves as a register with the other 4 angles, for the direction of the fire. If the artist wishes to use a furnace, melting, calcination, cementation, or reverberation, he can do so after having been the top of the bricks which are built on the side, as well as the bars, so that he can introduce his vessels and his materials more freely and more easily. This is what we had to say about the furnaces, which are built with lut and bricks. It only remains to say something about the lamp furnace, which can be used by the most curious in several chemical operations. This furnace must be made of good boleous earth, which is compact, well kneaded, well alloyed, and which is well cooked, so that the heat of the lamp cannot transpire, and so that this does not happen, we can make a coating inside and outside the furnace, after it is cooked with egg whites, which are reduced to water by continuous stirring. This furnace must be of 3 pieces, which make in all the height of 20 and 1 inches, that it be of the thickness of 1 inch, and that it has inside 8 inch in diameter. The first piece of this furnace, which is its base, must be 8 inches high. It must be pierced at the bottom 4.5 inches in diameter, so that this cover can be used for the introduction of the lamp, which must be 3 inches in diameter and 2 deep, that it be round and covered with a plate which is pierced in the middle of a hole, which can receive a wick of 12 threads at most, and that there are still 6 other holes of the same size, which are proportionate to a distance equally far from the middle one. The second piece will be 7 inches high. It must fit right into the first piece, and have 4 legs of the ground that are 1 inch across, to support a vessel of clay or copper, which will be 6 inches in diameter and 4 high, which will serve as a bain-marie and as a capsule, for the ashes or for the sand. This second piece must also be pierced with 2 holes opposite each other, which are 1.5 inches in diameter, to which 2 Venetian crystals will be fitted. These 2 holes must be made between the height of the 4th inch and the last of the height, which will serve as a window, to see the change of colors in the operations, as also the dissolutions, by opposing a lighted candle on one side and looking on the other, because the vessel and the matter it will contain will be between 2. The third piece of the stove must be 6 inches, to complete the 21 inches of the whole height, which must be made in a dome or hemisphere, which is pierced at the top, with a hole 1 inch in diameter, which receives several pieces of 3 lines each, which always shrink to a button shaped like a pyramid, which will close the last one. There will have to be 4 more holes in the same way. But what is most considerable for the observation of more or less heat, is seen by means of the thermometer, which is a glass instrument, in which one puts water, which marks very exactly the degree of heat, by the lowering and raising of this water. We can rectify the oils, which we will use for the lamp on fixed salts made by calcination, so that they make less soot, and that they act more powerfully, since this rectification removes their excremental humidity and their superfluity. The wicks must be gold or feather alum, or asbestos, which is a mineral found on the island of Elba, which can be substituted with the internal marrow of elderberry or rush, which is well desiccated, which will have to be changed from 24 hours to 24 hours, which makes it necessary to have 2 lamps, which will be substituted one for the other, so that there is no intermission of heat. If the wick of elderberry pith is used, there must be a small sharp point of iron which is soldered to the bottom of the lamp, and which corresponds to the middle of the hole in the lid which must contain the wick. The figure of all these furnaces will be seen in the plate, which is at the end of this chapter. It is only necessary to say 2 more words about the iron instruments which are necessary for the furnaces, for it is necessary to have pliers to pull the crucibles from the fire, calves or tweezers, a scraper made of hook to clean the grids, and a shovel iron to pull the ashes. It is also necessary to have an iron cone, forged and well welded for the jet of regulus, whose figure we will also see with the glass instruments.